Um, I can't share my screen. I'm disabled to share. Can someone please allow me to share? Okay, thank you. Okay. Please, can you see my screen?
Yeah, I can see.
Okay, thank you. So we are tackling object-oriented programming. Object-oriented programming. Um, but before we hit object-oriented programming, let's just take a step back to what we did before object-oriented programming, which was classes. Something brief. What do we know about classes? So what do you know about functions? Yeah, functions. We did functions before object-oriented programming. So what do you know about functions? We know functions are like containers. Basically, they're like containers, and each container has a label. So it can be, for example, let's use a kitchen analogy where a container can be like a spice with a label spice. So, when you want to take spices, you have to take this container with the label spice, a clear label. Or if there's salt, you have this label with salt. So we can easily tell the difference between the spice container and the salt container. And we put only spices in the spice container, and we only put salt due to these labels and the container. So that's basically what functions are. They are containers that hold a code or um, data of the same value. Okay. So if we are already structuring our data with functions, then why do we need classes? Right. So let's use more like a practical scenario where something we have accounts an account as a way to understand what object-oriented programming is and why do we need object-oriented programming and how is it different from functions. And when will we use object-oriented programming and when will we use functions? So in object-oriented programming, like I said, object-oriented programming is, so if using the analogy of a bank account, right? Each and every one of us has a bank account, I'm assuming, and your bank account has each and every one's bank account has certain behaviors or certain features that you can do per your bank account, but it's the same that cuts across everything. So if we all having one bank account, we can both check our balance, we can all withdraw, and we can all deposit. You get me? So in this case, the balance and the deposits and the withdrawals are methods, and these methods are also containers, right? Which has the same, which also stores data of the same of the same value of the same interest. So we know when we go to the container of balance, that's the method. This method balance over here. Let me go down. This method balance over here. This is a container that has only information that has to do with balance. If I want to deposit, I know, okay, in my account, I can go to the deposits category, right? Which would allow me to also deposit money. I won't have to go to balance to deposit. If I want to withdraw, I'll tap on withdraw or I'll go and tell them I want to withdraw and I'm allowed to withdraw. But I won't go to, I won't take the deposit slip or choose deposit if I want to withdraw. So with this scenario in mind, with this scenario in mind of it's being structured, everything is under something, and which is under your account. So if it's Mr. Andrew, everything is under Mr. Andrew's account. So in this case, the account is the class. Mr. Andrew's account is the class, and his ability to check his balance separately, and the ability to also deposit money separately and also withdraw money separately. These are the containers or the methods that are inside the account. So this allows you to this object-oriented programming in this scenario is allowing you to properly structure your data or structure your bank statements, knowing where to go, knowing which accounts to go to, and if it goes to that account, okay, if this is Mr. John's account or Mr. JB's account, this I can check my balance, I can deposit and I can withdraw. So that is the basic concept of classes, where the class can, in this case, the account, which is the class, represents one person's account, but it has the same functionalities as Mr. Andrew's account, the same maybe Mr. Steven also has the same account, but he can also do the same thing as also having checking his balance, depositing, and also withdrawing. So all of you have accounts, but entirely separate accounts. But you guys can do the same things all over and over again per your account. So in this case, your account is your class, and whatever you can do in your account, that is if you can withdraw, deposit, or check your balance. That is the method. That is the methods in the account that you can do individually per your account. Um, up to this point, do you understand what the idea I'm bringing? You can just you can use an emoji to just a thumbs up emoji or something. No need to unmute if you understand what I'm saying. Okay, thank you. So with that analogy, let's go a little technical to what a class is. Let's just so I have some resources here. It says a class is a data type, right? That provides a framework or creating for creating objects, right? And you can define classes to create multiple objects without writing additional code. So just like what is this is saying, a class over here, that's what it's saying is a data type that provides a framework for creating objects. You can define a class to create multiple objects. Come again? Hello? Hello? So I didn't hear what you said. Mr. Gabriel.
Okay, I think he joined and his camera was on mute. Sorry, his mic
Oh,
was.
okay. If you want me to go back, if you just joined and want me to go back, let me know. I'll go back so that you understand. So in this case, the class here, you're saying it's a data type that provides a framework for creating an object. And this is the main part. You can define a class to create multiple objects. Over here, you can create multiple objects without any additional code. Now, what does that mean? In the scenario of the account creation. So the framework here is your account. Like I said, everybody has an account, and although it's a different account on it entirely, we all can perform the same functionalities by checking balance, but it's the same account. So this account is the framework in this case, right? Oh, sorry. This account is the framework and used for creating objects. I'll let you know what objects are in a second. Here you can define multiple objects without writing additional code. As you can see here, it's just one code I'm writing. It's everything just one class. I'm not writing plain. So it's just one class account. So the object here is in the scenario given. Maybe that is one. An object can be Mr. Stevens' account, and another object can be Mr. Isaac's account, and another object again is Mr. JB's account. So the objects are the users' accounts. So like you said, you can create multiple accounts without writing any additional code. So like since we all have the same accounts and the same um behavior. All our accounts has the same behavior by all checks balance, all we can also deposit and withdraw. Although we have entirely different accounts, we can still use the same structure or the same framework throughout. So we can have John's account over here, an object. We can have let me someone Mr. Isaac's account. I can do this. Sorry. Mr. Isaac's account over here. So we can have Mr. JB's account. Right, Mr. JB. Yeah, Mr. JB's account over here. And these are the objects. That's what he's saying over here, the objects. These are the objects. John is the account. This John has an account which can check balance, which can deposit, and which can withdraw. Mr. Isaac also has his own account, entirely different from John's account, which can also check balance, deposit, and withdraw. Mr. JB also has an account which can also do the same functionality. So I don't need to write multiple codes. So I want maybe go to Mr. John and write this whole thing all over again, Mr. John, and come back and do the same thing all over again for Mr. Isaac and Mr. JB because it all follows the same framework and the same structure because it's the same account. Although it's entirely different accounts, you have the same behaviors. So that's what an object is. We'll go more into that if you we'll go more into that in a later time. So here it is what's a method. A method is a function that performs a task or action. For example, a method may return information about the object's data. So in this case, um, in functions, you have we know we can define functions just like this: def, deposit, the function initialization syntax, the a name to represent the function, and a return statements. That's but anytime you see something of this sort in a class, it's considered a method. So in a class, a function is a method. So from now, we're using methods. I'm using functions because we are talking about classes. So this is a method. A method is a method is a function like it said over here. So here is a method that can perform a task or action. For example, a method may return information about an object's data. So in this case, we have this method that returns the balance of the data. So if I want to check, I'll explain some additional code you are seeing over here very soon, don't worry. So let's see, I want to check um, Mr. John's account, right? Over here. So if I print current balance, let me print current balance of Mr. John. So the current balance of Mr. John is 100. That is the 100 we've kept over here because it is accepting a particular parameter. The parameter is set to 0 for the meantime because that means you don't have any amount of money. Yeah. But maybe he has currently this amount of money he has initially when he deposited or something. So if I want to check the balance, this is returning an information I need from a method. So like I said, the method may return information of an object. And this particular information we need was for balance. The same way if I wanted to deposit and check the amount I have deposited, I can also call the deposit method. And when I print that, I'll know, okay, now I have 150. That's after I deposited, I have gotten 150 Ghana cedis. This is Ghana cedis in this case. So that is basically what the method does. And the method can take an input or cannot take an input. So I can take this out. I could have taken this out. So, I could have let me take this out. Take this out, and I could have just like 0 over here or 100. And I wouldn't need to put any input over here. And when I run current balance over here, let me have this. I'll get 100. So methods you can choose to give a method a parameter where it can take an input or just don't take any input. Just return this for me and it returns it for you. Yeah, but this is a bank statement, so I don't think anyone would have this a static account. So let's go back here. So that's what a method is. And now what's an attribute? So the attribute, this structure stores information about an object and defines a state. You can define an attribute as part of a class. Yes, I'll explain the part where you can define an attribute as part of a class soon, but this is an attribute in a method. This is what we just defined over here. The same way balance and amount is also an attribute. So they store information, and this information is what we can use to perform any functions. Like in this case, yeah, in this case, this deposit needed the balance attribute. Yeah, did someone speak? Or I should continue? Please, do you understand up to this point? Or if you want me to start again, and I'll be glad, no problem. Or if you want me to continue, just give me a thumbs up and I'll continue. Okay, seeing the thumbs up. Okay, great. So don't hesitate to pause me if you don't understand anything. Okay, someone says, can we start again? Okay, no problem. Okay. So I think okay, let's start again. So I was talking about object-oriented programming, but I took a step back to talk about functions. What are functions? And I said functions are containers, right? So in, like you say, a kitchen-based environment, we have a container that has our spices labeled as spice, and we have a container that has salt labeled as salt. So if you want to take the spices, you just have to check the label. Okay, this is the container that has my spices, and I take my spice and I take such an amount I want to put in my food, whatever I'm doing, and I look for my salt and I take it. the same thing. So the container in this case is the function, and the spice or the label is the name of the function. So that's basically what a function does. It stores info. It performs. Um, it structures data for you. So you know, okay, if you want something, you are just going to this structure or this container to go and take it. So that is basically what a function is. And I was asking, if you need a function, if functions are structuring our data for us, why do we need a class? What's the purpose of a class if you can just structure data in a function? So using an account-based system as an example, since we all have accounts, we all have accounts in this world. Some will have Fidelity accounts and Ghana Commercial Bank accounts, but they all perform the same functionalities. Maybe some will perform additional, but they have certain basic fundamental functionalities, and each account, each and everyone's account would perform. So in this case, you may have an account that would be able to check your balance. That is like a very basic functionality of an account. You must be able to deposit if you have an account. You must be able to withdraw if you have an account. And Mr. Gabriel's account is different from Mr. JB's account, which is different from Mr. Isaac's account. But they all perform the same functionalities. They all check balance, they all deposit, and they all withdraw. Maybe depending on the bank, you can have additional features. You get me? But in this case, we are using the basic ones, which every bank account should do is at least this thing. And so in this case, we can say the class is the account and the balance is the containers I was talking about. So the category balance will return only balance. So if I want to check my balance, I know I just have to go to in my account, which is the class. So the class, I'm entering my account. And in my account, which is the class, I can check my balance. And which is entirely different from me depositing. I can also deposit if I want to, which is a different method altogether. And I can also withdraw if I want to. So in okay, yeah. So to the basic how to just create an account a class. Let me just show you how to create a class. The most basic way to create a class is to just say class, the name of what you want to do. So in this case, for me using the kitchen-based approach, I just said, okay, so I have a kitchen, which is my class. In my kitchen, I would. So this is the most basic way to create a class over here. So they are saying it's a framework over here, in which I will explain soon. So with that, going back to the accounts based example, each and everyone has a different account, but we all perform the same functionalities, like I said. So in this case, the account is our class, and the functionalities that all the functionalities in the account are what we are performing. What that we are doing is part of that class. That class is only your account. So if it's Mr. JB's class, Mr. JB's account is Mr. JB's class. And Mr. Isaac also has the same account class, but it's specific for only Mr. Isaac. And I will show you how that works. Yeah. So let's with that idea in mind, Gabriel, please do you understand? So Gabriel, do you get to that scenario so that I can move on? Okay. So with that scenario in mind, what is a class? It's saying a class is a data type that provides a framework for creating objects. You can define a class to create multiple objects without writing additional code. This is one of the important things about classes. You can create a class to create multiple objects without writing additional code. So a class is a framework. This is a framework. Just this simple thing you've seen is the framework. So this is how to create a class. Simple as that. Now let's talk about. I don't want to be using two examples. So let's stick to only the account. So in this particular framework we are seeing, it said it defines it's a framework for creating objects. So this particular framework has particular behaviors and functionalities inside this framework, right? So what are these objects that they are saying? Because it's used to create, it's used for creating objects, and it's used for create, and we can create multiple objects without writing additional code. What does that mean? So right now I have Mr. John, and Mr. John has this account, and this account performs this same thing as Mr. John's account performs these functionalities, right? I can also have Mr. Gabriel's account, right? Which also takes this same class account, which also performs this same functionalities as the account. So although Mr. John has his own account and Mr. Gabriel also has his own account, they all perform the same functionalities, and I didn't have to write a code, or we didn't have to write like the code over again for only Mr. John and also write another code just for Mr. Gabriel. How they do the same, how they perform the same functionalities with the account, the same basic functionalities with the account, which will be more, which in coding it will be time redundant, as in repeating code over and over again. So classes helps us to reduce that, just have one class or one structure, one framework of interest, and you can just pick, you can create objects. So in this case, the John is the object and Mr. Gabriel is the object in this case. So these objects are different, entirely different. They are in separate memories. Let me see. I think I can show you that. I don't need. I think if I take out this, yeah. If I take out this, it should not give me an error. Should it? Oh, okay. Um. Okay, okay, let's do this. So let's let me show you which memory. So if I return balance without, let me return balance over here without any calibration. So I'm not supposed to get an error, man. Oh, um, for now, let me comment out all these. So we're getting errors. I want to show you something. So, um, okay. So current balance. Yeah. So as you can see over here, Mr. John's account over here, this is where it's stored. So if I have Mr. Gabriel's account over here, and I also see print Mr. Gabriel's balance, right? Mr. Gabriel dot balance. Realize they are both of the same class account, but if you look at the objects, they are in different objects. If you can see over here, this is in the memory location here is 7610. The memory location here is 5A50. If although this is the same, but the memory location is different. So this is one object of the class. That's talking. This is the object. That is, this is Mr. John's memory, where Mr. John's account is saved, and this is where Mr. Gabriel's account is saved. So this here, what you are seeing here is that is the memory location of Mr. Gabriel's account, and what you are seeing here is the memory location of Mr. John's account. So although it's just one same class, it creates an object. An object is like a duplicate, or it's like, yeah, it's like a duplicate, but you can still perform the same functionalities without having to write code over again. If I'm not making that clear, let me know. I'll repeat what I just said. So the duplicate, so that's what an object is. We'll talk more about objects too, for you to understand in future. We'll talk more about it. So let me go back. So that's what a class is. It's a framework. That's what we are seeing over here. So now what's a method? A method is a function that performs a task or an action. For example, a method may return information about an object's data. So in this case, an object is, they said, is a function that performs a task or action. So we know initially back before we did object oriented, we're doing functions, and this is the same way we create functions. We have the we initialize a function with this keyword, then we have the name, we add a parameter, and we return or we perform any functionalities inside the function. Yes. But in this case, in classes, when you see this same structure or this same syntax, it's considered as a method in a class. So we can say a function is a method. A function is a method in a class. So a function that we're performing inside a class is a method. It's considered a method. So I won't be saying functions, I'll be saying methods because I'm using classes. If it wasn't inside a class, you can say functions. So this method, like they said, holds may return information about an object's data. So in this case, this particular balance method is returning the balance of the current user who is checking his balance. If it's Mr. John, if Mr. John wants to check his balance, we excuse me, John wants to check his balance. All I have to do is, let me see, John's balance. So if Mr. John wants to check his balance, you can see over here that when I call when I don't worry, I'll show you the syntax of the code. I will show you that soon. When I call Mr. When I try to check the balance, all I have to do is just check only Mr. John's balance over here, and I'm seeing 100 because I kept in 100 over here, and that's just my Mr. John's current balance. So the same way I can do the same thing for Mr. Gabriel, where I would let me use G's current account. Gabriel. And let me use let's say 200. So if I print this too, you can see Mr. Gabriel's account is 200 and Mr. John's account is 100. So that is the method over here. I'm returning this particular method, which is returning an information I want. So if I want to deposit to, I would return this method, which would allow me to add an amount over here to my balance, and I'll get what I want to. So let me take out just Mr. Gabriel for now. Let's only focus on Mr. John. And I print this. You realize I have 150 because I added 50 to my current balance over here. Let me take this. I added 50 to my current balance over here. That is 50 over here. And I got 150. So because I wanted to deposit, I called the deposit method and I was able to add an amount of money to it. So that's what methods are. They are functions that perform a task. And a method may return information of an object or data, for example. It can also do other things. It can perform computational operations or any other operations you want it to give, depending on the particular project you are working on. So in this case, we are working on the accounts. That's why we are returning this particular. That's why we are returning the balance after it was deposited. So now that we understand, please you understand what methods are? Just a thumbs up if you understand what methods are. So I move to attributes. I would have an example. We'll have examples to help you clarify this very soon. So okay, thumbs up. So what's are attributes? Attributes are arguments or parameters. Yeah, they're parameters that allows you to input something into what a method or a class, because it says over here that attributes store information about an object. It stores and defines its state. You can define an attribute as part of a class. This part I will show you how you can define it as part of a class. But in this case, we are defining it inside the method of a class. So this is an attribute. That is why I was able to enter 100 over here. If not, if I didn't have an attribute over here, then I would have to hard code the 100 over here, and even I think yeah, I would have taken this out. So if I had printed, I think this is confusing. So let me take everything here. Yeah. So if I had printed it's sent here, there was no parameters, there are no attributes over here, but I just returned 100. So I didn't add anything inside the balance method, but I still got 100 because I had written it here over here. There was no attributes. I didn't add any attributes here. But so attributes are attributes are stored information basically. So depending on what you are doing, you can have an attribute in your method to store a particular information. You can use that just like this place just like this particular place where I took the balance attributes and the amount attributes and I added both of them together. So that's what attributes are. They store information and you can perform operations and other things you want to perform depending on what you are doing on these attributes that you've defined over here. So you've declared over here. So that's what attributes are. And now what are objects? I think I have explained what objects are. That John is an object of this class and Gabriel is an object of this class, because although they are all having, maybe Mr. John is using Fidelity account and Mr. Gabriel is using maybe a Ghana Commercial Bank account. I don't know their bank accounts either. So, but they all perform the same functionalities. You may even have the same, yeah, maybe be in the same bank, or you both have a Fidelity bank account, but you are both having different bank accounts. So Mr. John's bank account is an object of this accounts class, and Mr. Gabriel's and bank account is also an object of this account class. So how is that so? How are we able to create these objects, and how is the class able to know that okay, Mr. John's account is different from Mr. Gabriel's account? How is it able to know? Because it's not magic, you know. That is where um, self comes in. This self statement we are seeing over here. So anytime you're writing a class, you always realize that in every method you create, the first parameter you always put is self. You can put anything. You can put anything at all. You can put anything. You can put maybe John or any name at all here. It's up to you. But conventionally, self is what you use for conventional purposes. So, yeah, self is what you use. So self, what self does is self takes this object. So it now says, okay, since I'm looking for John's balance, I'll explain the syntax in a bit. It will take John over here as self, not Mr. Gabriel. So it knows it's interacting with John at this point. And the balance that I'm inputting here is for John, not for Mr. Gabriel, because the self over here is for Mr. John. That is how it creates the object. And if Mr. Gabriel also wants to put an amount, it picks Mr. Gabriel and puts it over here and says, okay, yeah, Mr. Gabriel is the self. And this is the amount Mr. Gabriel wants. That's why when we called the same class, but when we kept in different parameters, it didn't add up or it didn't merge it together. It gave us entirely separate accounts. And this way in a real world scenario it helps with data protection. Because in functions, back in functions, yeah, Mr. Isaac, you have a
Okay,
question.
so thank you. I think I'm following. The
Okay.
So the self, if I understand, anytime you want to create an instance of the class, you have to
Yeah.
introduce, right,
Yeah.
in the
Yeah. So the
methods.
self is yeah, exactly. So it's something that even so if I take out self right now, it will give me an error. It should give me an error. Yeah. Balance takes zero to one positional argument, but we're giving two. The self is something that you would have to put in um something that you would with Mr. Isaac is your hand still up. This one okay. So the self is something you always have to put into a method, and it's anytime you're creating a method. So even if I take balance out, right? This is not an attribute. This is kind of an attribute, but it's not an attribute that you can replace if you realize. So I can't. So self over here calls this account, and this account belongs to this Mr. John. So the self here is for the account who calls Mr. John over here. So the self is not like an attribute where we can input balance and amount. So that's one difference between functions and methods. So in a normal function, we could have just done BF balance outside the class. We could have just done this. Return maybe 10. This is how a function is. It doesn't need a cell because it's not in a class. But this is something that you would always have to put in a method all the time because that is how the class or Python is going to know that, okay, this self is talking about account and this account belongs to Mr. John over here. So this instance is for Mr. John. That is why we are using the self. So without this self, you can I can see 10, right? It won't ask me for a positional argument. People tell me that there's an argument called self over here, and I'm not returning anything there. Like if I was supposed to, I think like the example I showed where I took out this. If I print it, I'll get 10 over here. Let me take out this over here. Yeah, I'll get 10 over here. Although there's an attribute, but it doesn't take this attribute as something that you are supposed to hold. It's automatically holding that information for you that okay, this self belongs to this account and this account is Mr. John. So it's holding it for you automatically. But if I was supposed to take maybe if I wrote balance again over here, balance, right? And I run this code, I'll get an error. Saying I missing one required positional argument. That means this has already fulfilled this, the Python has already done whatever it wants to do with self. But you have to work with balance. So it tells you missing one required positional argument balance. So that's in in a normal function, the same way where you would have if you would balance and you just did balance over here. and you didn't return balance, it would have told you that error. So that's the difference between a function and a method over here. The self attribute argument is always called anytime you create or anytime you initialize a method. Always call it first, because that is, as you can see, even as you can see over here, I don't want to move my mouse, but you can see that they've written parameter self, which is self at account. So the self is talking about the class called account. It is referencing this account, which belongs to whoever you assign it to. So if this account belongs to John, then it's Mr. John's account. If it's Gabriel, Mr. Gabriel's account over here. That is the power of self. So let me do this. Okay, good. So please, you understand self. That is how we are able to. That's how self allows us to create or instantiate objects. Just like the way I was able to freely create multiple objects or multiple people without having to create a class again for people all the time. All I needed was maybe just the information of the information that I needed in the methods. So that is what objects are. And with the help of self, we can create objects. Am I being, can I, should I iterate over that one more time? Or do you think we are cool? Let me get a thumbs up if everything is cool, or a thumbs down if you think I should iterate. Yeah, Mr. Enoch, I think your line is, you can type if you're having an issue, or
I think the pace should come like
mhm.
one distance to one, so that we can.
Come again.
I think if you take the pace a bit slower, it will help.
Okay, a bit slower. Okay, no problem. No
Yeah.
problem. So, should I iterate to self again, Mr. Enoch? Should I iterate to self again?
Yes.
Okay. Or do you want me to go back a bit, or self is okay? From self, I should move from self.
Let's do so.
Okay. So let's talk about self. Let's talk about objects again. So, what's an object? Then an object represents an instance or creation of a class. Objects define specific data, such as properties and behaviors, to implement code. So object is represents an instance or creation of a class. What's an instance? What's a creation of a class? So in this case, um, if we just go outside coding a bit, and we're saying account balance. If you are going to create an account, right? What's your bank needs? It's probably your information to create your account. It doesn't need you to manually define balance for you again or deposit. All it needs is the same. It just needs your information to create your account, and that account has the same information as another person's account. So if Mr. Enoch and Mr. K both went to Fidelity to create an account, they have their own unique information, but their account behavior, account behavior, the things that accounts can do, is the same. Just that Mr. K's account, what he can do with his account, as in if he's deposited 100 CDs, it won't reflect in Mr. Enoch's account, because Mr. Enoch also has maybe 200 CDs. No, we are rich people, so let's say 10,000 and 10,000 and 20,000. Do you get it? So in this case, that's an object. So if Mr. K creates an account in Fidelity, that's one object created. And that object would have all this information. That is, Mr. K can check his balance, he can deposit, and he can withdraw. If Mr. Enoch also goes into Fidelity and also creates an account, that account would also have, which is although the account is different from Mr. K's account, it has the same behavior, so he can also deposit, withdraw, or check his balance. So that is, although we are both having an account and which has the same thing, it's entirely meant for one person and another person. So you can input, so Mr. K can decide to put 10,000 Ghana cedis in to deposit, and Mr. Eno can decide to put 15,000. It is per their particular requirement. So in this case, the object here is Mr. John. He has created an account. Yeah, he has created an account. Mr. Gable has also created another account. this, so what it does is it creates or it instantiates this particular class. So that means this line of code has created this whole class for Mr. John. So Mr. John now is an object which can perform everything this class can do. Mr. Gable is an object who can perform everything this class can do. So I can say I want to put a balance. I want Mr. John is wants to input Mr. John's balance is 100,000. If I print this, you can see Mr. John's account over here is 100,000. So Mr. Gabriel over here, oh sorry, Mr. Gabriel over here will also have another account. So let's say G accounts. Yeah, let me just Mr. Gabriel's current balance over here. And let's do it, Mr. Gabriel. And let's say he is doing 1,500, right? So if I print Mr. Gabriel's balance to 6,500. So although it's the same class we are all inheriting, all the same class we are both that we are both using, it is creating let's say a separate class for Mr. John, which has the same functionalities, and Mr. Gabriel also has created accounts which has the same functionality. So if Mr. John inputs 1,000 CDs, 10,000 CDs, sorry, in his has a current balance of 10,000 CDs over here. Mr. Gabriel also has the same balance of 10,000 CDs over here. It's entirely different. It's totally different. Although they're performing the same behaviors, their bank accounts are totally different. That is why in banks you can't without your information or without a particular yeah authorization, you can't get into someone else's account, because although they are all having the same functionalities, each account is respective to the owner or the creator of the account. So I even mentioned, I think I showed an example where I can show it again, where let me just do this over here. Let me not confuse you. So let me until you can see, just to show you how the objects are created. Let me see 10 over here. Yeah, this is how objects are created, and to even when the object is created, it doesn't have the same memory. That means it creates all this structure again in the back behind the hood of Python, and you can perform all this inside. So if I'm supposed to take this out, let me take this out. Let me take this out. If I print this, you see that it says bound method, account balance of main account. So the main account here is this account class here. So you are both having an account class. So that means you are both having this same class, and it's also a method. So this particular balance here is the balance method they're talking about here. So bound method account balance is this balance method over here. And it's saying that main account object at this particular gibberish. And this what you are seeing here is where it is stored in the memory. So as you can see, if you compare this and these two memory locations, you don't need to understand this. I don't even understand this myself, but yes, just know that these are where it is stored in the memory. But if you compare these two memory locations, you can realize that they are entirely different. Even look at the ending, it's 1480E0, 148E0. This is 5690. Although it's the same account, but we've created an object or we've created an instance. And this instance is creating this account all over again for Mr. John and creating this all over again for Mr. Gabriel. So they are both in different memory locations. And how does the class know that, okay, John has this account and John has this location and Mr. Gabriel has this location? That is where that's where self comes in. Because in order to know which location to take the balance from, each memory location to take the balance from, it needs to know which object it's talking with at that particular moment. So let me bring everything back. So in this case, that's how we have self over here. So in methods, unlike functions we did previously, that we can just do df balance and just it's called the closing brackets with now nothing. Anytime you are creating a method, you must always put in the self parameter. The self parameter or attribute doesn't do that is for Python to work out. You don't have to do anything with it. Even if you see, if I have over it, you can see that it said no, it said something over here. Yeah, it says parameter self. And which is what is self? Self is at account. So self belongs to this account. So self means self is calling the class itself. So self is calling class. And I said earlier that self can be any name at all, can give it any name. But conventionally, self is what is used, but you can give it any name. So self with self is returning this account class. And it checks, okay, which account does this belong to? It belongs to Mr. John at this particular moment. So if I'm printing Mr. John's balance, it will give me only Mr. John's balance. If I create another account called Mr. Gabriel's account, Mr. Gabriel's account would also, this self will check, okay, this is this account. Who does this account belong to? Mr. Gabriel. So it's now create an object for Mr. Gabriel. And anytime I'm calling balance, don't go and pick Mr. John's balance for me, but to pick Mr. Gabriel's balance for me, because that is the object or that's the instance I have created. When you see me saying instantiate or object, I'm just creating, I'm just creating a duplicate or the same thing, but it means the same thing, instantiate or create an object. So this two, I'm able to create these two accounts, although we are having the same class. So that is where objects comes in. It creates an instance or just duplicates it for you. It's like when you go to an bank account, and a bank are creating, two people are creating the same account. You have your own unique accounts, and everyone also has his own unique account, but it all performs the same functionalities. So that's basically what objects does. And self allows Python to know which particular objects over here we are trying to access. So if I say Mr. Gabriel, it doesn't give me Mr. John's balance, but it gives Mr. Gabriel's balance. That's why when I ran it, I was able to get these two entirely separate balance. So that is the main thing you need to know about object-oriented programming: a class, a method, and an attribute and an object. And we know what classes are. That's the framework. The method is the function or the action that is performing, and the attribute is the place. What's It's an object. It's a structure that stores information. That is what we are putting over here, and the object is what we are creating over here. So we can create you can create hundreds of accounts for each and everybody, but we won't have to repeat this code ever again. And when we update this code, it updates everyone's account. So if I add maybe um, a different method over here, it would automatically update everyone's account, Mr. Gibbons account, everyone's account, without having to manually go to Mr. John's account and create that same method and come back to Mr. Gibbons account and update it. Just updating it over here would allow us to would cut across any object or any instance we've created, just because they're all inheriting or they're all picking everything from this particular structure. Is it so far? Do we understand what classes are and what object-oriented programming is basically? Do we understand the concept of it? Can give me a thumbs up or a thumbs down if you don't. Okay, Mohammed says a thumbs up. Please don't hesitate to let me know if you don't understand anything. So now that we know about this, let's deal with syntax a bit. Let's do more of syntax. So we know how to create a class. Like I said earlier, if you want to create a class, all you have to do is just create a class, maybe a kitchen, and that's it. I've created a class. If you want to create a method, you would basically call it like a function, but in this case, a method, and I'll say maybe spices. But that's the container I have, spices. And I'll always put self inside because it's a class and it needs to know which spice, because I have different spices, it needs to know which spice I want. Then I can choose to put an additional parameter, in case I want to add any parameters over here to perform any computation. If not, I just leave it and I can return anything I want. Maybe one. It's how you create a class. So simple. It's very simple. Nothing else. Just how you just create a class. You call the class. You call the class, and that's it. You've created a class. So when you're creating classes, this is the first thing you do: create a class and the name. And mostly classes they begin with uppercase. So you can see cases where there we have types of cases. We have camel cases and all that cases, but most of the time, when people are creating classes, just to differentiate between a class and a method, the classes has they use uppercase for each first letter. So I can say accounts, operations, and I'll use, since there are two different words, I'm using caps again for the first letter. So each first letter, so each first letter of each word is capitalized. That is upper camel case, and the methods use small lower cases. And also the same way in functions you can return, in balance in methods you can return. So with this said, right here, let me there's a better way we can do this. There's a better way we can create classes. As you can see over here, I'll explain this in a bit, but let's just ignore this. When you are creating an object of a class, what do? You would, yeah, you would define the particular account you want. In this case, it's an account, so I want to use names. So John is the account I want. So John is the name of John is the name of the object I'm creating. So if I want to call a class, if I want to instantiate a class, I call the account class, this class over here, and that's what is here. And I put it in squarely sorry, I put open and closing brackets associated to it. This is how we instantiate a class. So even just here, when I instantiated Mr. Gabriel's account, I did the same thing. This is how we instantiate a class. And when we do this, now anytime I want to perform a function or anytime I want to perform a particular operation within this class, I want to call any of these methods. So I want to perform any method, any operations. I just need to call the variable or the instance I have created and perform what I want to do. So in this case, I'm saying, okay, I want to check the current balance of John. So I say, okay, current balance is equal to John dot balance, which is this account over here. That's this John's account over here dot balance. So what it does is it goes to self and says, okay, this is self is my account, and which account this account belongs to John. So I'm calling John dot, but so this is used to create, this is used to call a method inside the dot operator is used to call a method inside the class. So since I want only balance, I just call the balance, and so this balance accepts a parameter. So I gave it 10,000. If I took that parameter out, I'll get an error saying that I need to add an argument because I specify that there should be a particular parameter over here or an attribute over here. So I need to add a balance over here. And when I print balance, that's it over here. When I'm printing the balance, it's giving me John's current balance. So when I want to, it's like, I think I made an example yesterday, but let me just go back. So just like in strings, if I say, okay, name is equal to let me say Steven. No, let me use Mr. Ivan. Let me go to Mr. Ivan. Mr. Ivan, right? And I have let's say number, which is equal to 3 right here. This, if we do a type, if you print, let me uncomment all this out for the meantime. Let me okay, no, let me create another cell so we can follow. Let me create another cell up here so we can follow what I'm doing. Yeah. Sorry. Yeah. So if I am supposed to print a type of name, it will give me class string. If I'm supposed to do the same thing for number, right? Number, give me a type integer. we know a number is an integer, but we didn't know if it belonged to a class initially when we. But everything we are doing, we're working with classes. So this Ivan over here, Mr. Ivan over here, is a string which belongs to a class called string. So I have instantiated the class string and I've assigned Mr. Ivan to it. So that means, so I don't need to create a whole, because the class string is a whole computation on its own. I don't have to create all that computation just to call Mr. Ivan again. All I have to do is just call Mr. Ivan, and it creates an object of this string and assigns Mr. Ivan to it. The same way, if I give it 3, it creates an object from the class int and gives me 3. And the same way, if we have certain methods we can call on this. So if I say name.upper, right? You realize that Mr. Ivan becomes uppercase. So the dot upper over here you are seeing is just like the dot balance you are seeing over here. These are the methods. So the dot balance is the method over here. So the dot upper 2 is a method of class string. The same way we have a dot append or dot no, append is for lists. What's integer? I've forgotten the integer interpret. So let's just stick to strings for now. So if you use a dot upper, we have a string. So we have an upper, everything becomes uppercase. If I had a list and I said, okay, 3, 4, 5, let's just numbers. And I want to append a number to, I want to add a number to 3, because if I print number right now, if I print number right now, I get, this. I'll get 3, 4, 5. But if I do, after this, let me say number dot append, and I give it a 7, right? And I print number here again. What happens? You see, the first number here takes this 3, 4, 5. But when I call the method of dot append, like initially this particular number didn't have any argument, so we just called it like a normal method. But in this case, we require an argument. So when I added this append 7, it added 7 to this list. What happens if I take out the 7? Tells me it takes exactly one argument, 0 given. That means the same way we kept an argument over here, this number also this number is also needs you need to, this particular method requires an argument. So if you don't add an argument, it will give you an error. So if I add, that's why I added a 7. So sorry. Yeah. And if I print this, oh yeah, let me print. If I print this, I get a 7. So in this same this is something we have been doing initially, but we didn't know they were called methods and they were called classes. So that's the same thing. So in this case, we are creating our own classes in this case for our own particular computation or particular project we are working with in this case. So with this same scenario, the dot upper over here or the dot append over here is a method which is like the dot balance over here. So we are just creating our own custom class now to help us perform or make our code easier and not redundant. So that is why so anytime you are calling a method inside a class, you use the dot operator to call the dot and add the name of the method you want to create. And if the method requires an argument, you have to put in an argument. If not, it's going to be wrong. Yeah, Mr. Ivan.
Okay, I want to find out, instead of the 7, if you put in 0, will it repeat the 0, or it will repeat only the 3 numbers without a 0?
If I put 0, let's try it out. Let's see. Yeah, he gave me 0.
So it basically means that any figure you put there, it will return that.
Exactly. But if you leave it like this, then to tell you that is when that means you're telling there's nothing here, nothing at all. So it tells
how
you.
do you create it? Huh? Maybe to avoid adding something, but to repeat exactly what you have in that method. Maybe
okay, if you want
only 3, 4, 5 without.
Oh, okay. If you want only 3, 4, 5, in this case, we've defined 345 over here. We've defined 345 over here. So all I have to do is just print it. Yeah. So like I said, each method has its own. We have methods that perform particular actions. So this dot append method you are seeing over here, the purpose of dot append is to add a number or to add another number to the list over here, because the number here represents this number objects. So I can have multiple objects like number and num. It's a different object. So here I can say 4, 5, 6 is totally different. But this number here represents this particular number object, and this append here, the purpose or the action of this method append is to add numbers to this particular list over here. That is why when we call
Okay.
append, you can't leave anything, because the purpose of it is to add something. So
Okay.
if we add something, then that means we fulfilled its action.
Okay,
Yeah. The
understood.
same way, okay, yeah. The same way if maybe we are depositing money, right? And I say dot deposit over here, I think, yeah, and I do a dot deposit over here. Let me comment out this, right? And this is it. So I'm depositing money. So I use John is depositing money over here, but I don't add I don't add the amount I'm depositing. I'm supposed to get an error because I don't know how much I should deposit. So the purpose of this deposit account, the purpose of the method of this particular deposit method requires the amount you want to deposit. So the method, so it depends. So some methods are there that's like you saw over here with the dot upper over here, dot upper, name dot upper over here. You realize that we didn't need to pass in any argument because it didn't require any argument. The purpose of it is just to take the current object, that is this string over here, and make it an uppercase. So when I do dot upper, it's giving me Mr. Ivan without any problems. So we can create classes the same way. So if I
Okay.
take out this balance, yeah.
I think the problem I'm having now is that you
Yeah.
operate the functions, but we don't know how to operate those functions. For instance, in some cases, you use the hash before
Oh, okay.
something.
Stephen, you didn't explain what hash is. Sorry. Okay.
Hello.
Sorry.
Yeah, I didn't
Yeah.
touch. I
So
didn't touch.
hash.
I was going to
Yeah,
do
yeah,
that today, but hacking can't come through.
yeah. So hash in coding in Python, when you use the hash over here, it means a comment. Mostly when you see people writing comments, normally it's for comments. So if maybe I want the person who is seeing this code to know this is an account class, I can say hash account class. This has nothing to do with the code. This is just like information. It's just information. It's just giving information or context to what you are doing, because sometimes the code may be a lot and you won't, and just looking at it is very confusing. But when you add comments, you can add comments anywhere. You can add comments here. Hash. It doesn't matter where you add it. And so maybe this checks balance. And I can have another comment maybe beside it again saying this is to deposit an amount. And also have a comment even just above here that says this is to withdraw. Yeah. When the moment Python sees this hash, it doesn't regard it. It doesn't perform nothing on it because it knows that this is just a comment. So the time you see me putting this here is I'm just commenting out the code because I may end up using it again. So I don't want to delete it. So when I take out the comments, you realize you see it becomes colorful again, meaning it's active. So the comments, anytime we see a hash before any anything before anything, it means it's a comment. You're commenting something out. The Python program won't add that when it's running the code. It's for the user to see, the person writing the code to know what he's doing, to know, okay, this particular method is for depositing money, as it's saying here in the comments. This particular one is to check balance in case you are giving the code to somebody else, or you just want to know, in case you don't want to get lost in what you are doing. And also sometimes it's a habit with, in case you want to use code, you want to use the code again, but at that particular moment you don't want to run that code, but maybe you use it later on, you can just put a hash before it so that the Python interpreter won't know that. The Python would see the hash and say, okay, I'm not running this. I'm only running everything without the hash, everything without the hash, and it runs that. And aside comments, we have this string where you can also write something. You can write anything here. And when you run it, let me bring this back. Yeah. And when you run it, what happened? No, this is supposed to. Yeah, this. Sorry, I think I didn't put it. Yeah, it's sometimes also to give certain. Let me see. Let me put it here and see if it works. I don't know why it was. Give me a second, please. Yeah, it's nothing is supposed to run. Yeah, you can see here nothing run because so there's another way of also writing. Sometimes in case you have multiple lines of maybe what are writing is in multiple lines. Maybe you're writing like steps. Maybe step one. Let me clear this. So step one, you're writing something. Maybe step two. Step two is something. You're writing something, and this is step one. You're writing something. Just to remind yourself on what you are doing in each step, you can use these three uh, quotations, these three, and just to know what you are doing. The Python will also, depending on how you're using this, Python won't run this. It won't run it. It will just look at it and skip it because it knows it is for you, the user who is looking at it, to kind of structure your mind and know what you are doing. So that's why the comment, that's what the hash is for. The hash is just for comments. You're commenting what you are doing so that you are not lost. Or anytime you give the code to somebody, like the way we are sharing the code in GitHub, anyone who sees the comment will know that okay, this is for to deposit. So anytime you see method, anytime you see a comment, just know that Python won't run it. Do you understand the comments?
Yes, please. Thank
Okay,
you.
okay, wonderful. Yeah. So is there anything else aside the comments that you were talking about that you don't know how to run? Yeah, Mr. Andrews. Mr. Andrew, sorry.
Okay, so I have a question.
All
So
right.
when we were printing, let's say John's balance and then Gabriel's balance,
Mm-hmm.
um, yeah. So you just put, let's say we have a value of thousands, 10,000 cedis and then 15,000 cedis. But then I realized when you want to print their deposit, you brought
Mm-hmm.
the current balance there
Mm-hmm.
as well as I think a
Yes.
value. Why
Yes.
not only,
That's
let's say maybe only in the deposit, maybe John's deposit,
yeah.
or maybe Gabriel's deposit.
Yeah. I like the fact that you saw that. Yeah, that's is I was getting there, but it's good you saw that you are quick to see that. Yeah, so I'm getting there, Mr. Angel, I'm getting there. Yeah. So I
Okay.
was saying that I think yeah, so since we know how to, so right now we know how to instantiate a class. And you know that if we want to call a method in a class, we put dots and the name of the method over here. And if the method has any arguments, you have to put the argument inside the method. But if it doesn't require any arguments like this particular, I know I want to know the if name. Yeah. I'll get to the if name parts soon. Yeah, I'll get to the if name parts soon. So um yeah, so what was I? Yes. So the class sorry, I've forgotten where I got confused a bit. I've forgotten where I was. So the class, yeah. So we know how to create the balance. We know that okay, when we want to call a method, we put the dots. We put the dots operator with the balance name, and if there is any argument, to put this. The same way, if you didn't have any argument over here, it had only self. It had only self, no other argument. That means we wouldn't need any argument, and we would have just called it like the way we call this over here, dot upper. So anytime you're calling a method, the dot and the name of the method. That is the method, the name over here. That's how you call a method. So that is the syntax of calling a method inside a class. So in this case right now, we wanted to deposit money, right? We want to deposit and withdraw money. But I realized that we have balance over here, but yet I'm still putting balance here again. Yes. So me doing current balance is equal to this is current balance. And when I'm depositing, I have to put the balance again over here. That's the balance over here, and the amount. So this is the same way as me doing 10,000, because and this is redundant. This is what we call redundant code. We are going to repeat certain things over and over again.
Okay. Chat.
Yeah, I've seen. Is the return balance the task? Yes. So when you're returning the balance, it is returning the balance that you kept over here. So if I'm returning something, I can return anything. I can return 5. It will print 5. That's the action that this method is doing. It's returning 5. But in this case, it's returning the balance we wanted to return. So the balance is the 1,000 over here we are returning. But if you realize, even here, it's a parameter. But this parameter over here doesn't mean this one here isn't related to this. Slightly different. I can say maybe I could have even used money over here. I've used money over here. Anytime you define something over here, it doesn't relate to anything outside. This is like an empty thing. It doesn't, even if it has the same name, doesn't mean I'm calling this. You can call it any name at all. It's just to show you that you need something here. So you can use a name, as you can see here, it's any. So you just have to use a name that would be relevant to you, so that in case you're making mistakes, you know, okay, I'm supposed to put balance here or money here. So with this same, I change it to money over here. So even if I change this to current balance, right? Current balance, I'll still get I'll still get 1,005. What happened? Oh, okay. So I'm coming. Yeah, 50. So I'm 50. Yeah, sorry. So I'll get 10,050 over here, and here I'm enjoying 30. So it subtracts. So this, although it's written money here, it doesn't mean that. So if it's balanced, whatever is inside this particular parameter doesn't associate itself to anything outside the code. This is just an empty value that is saying, okay, you need to put something here. So no matter anytime you put something here, anytime you put a parameter inside a method or a function, even in a function, even if it has the same name as a variable that you've defined, it's not related to that variable in any way. It's just telling you that, okay, hey, there's something here that you need to put. So if I'm not putting it, that means they'll give you an error. Yeah, Mr. Steven.
So my question is with respect to balance. So I can see that we have not the function, not the method balance, but the property balance. So my question is, why is it that, or how is the class able to remember that the balance I'm working with is 1,000 and I'm adding 50 to that 1,000 and I'm subtracting 30 from that 1,000?
Yes.
How is it able to do that? Because I don't see any connection.
Yes, exactly. Yeah, I'm getting there. That's what Mr. I think Andrew raised. I'm getting there. I wanted to just explain something
Thank you
on
very much.
redundancy, but I'm getting there. Yeah. So I'll get there soon. So, like I said, so this particular thing is just any name you can put. So you can as well just put 100 or 10,000 over here, and it will still run. So why that means it is useless to just put this over here and come and put this over here. It is just redundant. You are wasting. It's like you are just repeating code, and it's very stressful because you can make a mistake where you will now put 2,000 over here, sorry, 20,000 over here, right? Then when I'm depositing, it tells me that instead of it being 10,000, as you know, my balance is 10,000. Now it's telling me I had 20,000. I'm depositing this. This is a bad way of writing code. Even if you even put this balance here, you put this current balance here, it is still not. Sorry, it is still not right to do that. Let me go to current. That means you are still repeating whatever you are doing. So that is where we have something called magic methods. Or magic method. Magic methods are these are magic methods. So these are functions that enable particular functionalities in a user-defined class. So, and magic methods help us. It helps the classes very well. It has this particular functionalities that and we have a lot of magic methods. Let me show you some examples of magic methods that we have. So even in the int class that I showed you, if I do dir int, you should see a lot of magic methods over here. And anytime you see them with these two underscores, these two underscores are called danders. So mostly you can hear people saying dander methods or magic methods. They are still the same thing. Dander just means these two underscores over here. And these magic methods allow us to perform specific functions. So what kind of functions are we performing? Let's show you the functions we are performing over here in magic methods. So in accounts over here, you realize I have restructured the initial class here where we had balance and the balance had balance class. The deposit had money and amount. Withdrawal had balance and amount. Let me just use balance over here. Balance and amount. Let's go down. Let's go down here. You realize something different. That we don't have anything called balance, a balance function, a balance method, sorry. And aside that, the deposit here doesn't take any balance method. That's like doesn't take the balance again, but all it takes is the amount I want to deposit and the amount I want to withdraw. Now, why is that so? Because of this magic method over here called, let's forget about this for now. We'll get there. Let's forget about these magic methods. So I've used hash, that means these ones won't run. It won't run at all. So this def underscore init. Let me clear this. Yeah. So that's this init over here. So this underscore init initialization is also called this particular one. This particular magic method can also be called a constructor. Why is init very useful? This is something that you'll be using almost every time when you're creating classes, almost every single time. Why is this useful? It's useful because when there's a class and you define def underscore init with anytime, like I said, anytime you define a method, you always put a self there. Accounts, this puts, this methods, all these variables you are seeing are saved into the method. It's an instance of the method, but this one becomes a class attribute. So these ones are in the class itself. Not these ones are just like sub-target methods, but this one is in the class itself. What do I mean by that? Is when I call this init method, it's first runs this method and saves whatever information that is here. And this information can be cut across. This information can cut across any other method that is inside this account. And how is that possible? As you can see, I just did a normal method definition where I did a def, but the only difference is I just called this particular magic method, this particular one. This is a keyword. So when you call this, I called self and added a balance. So this balance right now is the balance I would input. That is the 10,000 I would input, right? So what we do is, although I've defined it over here, I need to initialize it. So let's self, and since we know self is this account, self belongs to this account. So I do a self.balance is equals, it can be any name, it can be self.low, it can be any name, but just to keep continuity, I'll do a self.balance is equal to balance. Most of the time, this is the convention you write it. If you see amount over here, most of the time you see the person doing self.amount is equal to amount. It's like a convention so that you won't get confused or you won't get lost in what you are doing. So just by doing this alone, just by assigning this balance to this self over here, everything becomes easy. Now I don't need to call this balance as I did over here. As you see here, I called balance over here. I had to call balance over here, and it was just a waste of time. I just had to call self.balance over here, self.balance. And I added the amount to self.balance. So let me run this and let me show you how this works, and we'll talk about it. So I'm saying my account, John's account is John is a rich man, I believe it. So that is 100,000. God lucky. Let me God bless him. So 100,000. And if you print John, oh yeah, sorry. So John is oh yeah, amount. I made a mistake. Sorry. Right now, we want the balance of John. We want to know the balance of John. So we initialize the balance here with the init method. We initialize the balance over here in this argument. We put the argument inside this init method because we know that this balance is what the deposit and the withdrawal is going to use, because we need to know how much we are going to deposit and add, and we're going to know the total amount after we deposit. We also need to know how much, if we withdraw, we need to know how much was taken out from the total balance. So this is like a primary thing we need. That will basically cut across all other methods. So when you know that there's going to be a particular balance or any particular attribute that is going to cut across almost every method you'll be creating, the best place to create it is inside this init method, because the moment you initialize it here, you don't need to call it again anywhere. So now that I know, so I've called John's account, and the beautiful thing is, if you look over here, when we did John account, we didn't put anything here. That was because we didn't have the init method over here. So we were assigning it to the method itself. We weren't assigning it into the class. So in this case, since we are assigning it to the class itself, we are assigning the amount of money to the class. So whatever happens, we'll just pick this amount and perform whatever is supposed to perform on the class. So I know this is John's amount. And if I print, I don't think it should work. Well, let me see. Sorry. I took in memory location. Don't worry about that. So I want to deposit money right now. So I say John.deposit. I didn't add this 1,000 anymore because it already knows by this self over here that, or inside this init method, that John has 1,000 and I'm adding 50, 10, 100,000. I'm adding 50 to this to John's account, to John's amount. So if I print, if I deposit it, if I say print new deposits, a new amount over here, and I print new amount, got none. Hold on. Me print. Me print this again. Nice. I'm getting none. Oh, sorry. I didn't return it. Yes. In the method, you have to return whatever you do. You have to return it. I didn't return it over here. So that was a mistake. I had to return this. And balance that's this is supposed to be correct, so I'm not getting a mistake. Syntax error. Give me a second. Supposed to return server balance. Yeah, this is correct. This one, I think that one was supposed to run. I don't know what happened. Plus or equal to. So I'm saying balance plus. Okay. So let me take this again. So let's say John's new amount after depositing, right? John deposited, let's say 5,000 in his account, right? If I print new amount, right, I guess 105,000, right over here, because I didn't need to add, unlike this one where I had to add the balance again. Where is it? I had to add the balance and add the money. No, since I knew that this particular amount is going to cut across everything, what I did was I just uh called, but I don't think I really need to. Let me just take this out so that it will be continuous. Yeah. So I just called join the deposit this amount, and we saw that it's added the amount it needed right now to account, and we got this amount. That is that's the beautiful thing about the init function. So anytime you are going to write a code, or you know a project you are writing, there's going to be this particular parameters or this particular attributes that are going to cut across every method. You just put it inside this init. This you call the init function and put it inside. So the init method, and you put the you would declare, so you would declare the attributes, and you would now put a self and you call them over here. So what happens is this 100,000 over here is passed into this, and the balance now is this. That is this 100, and I'm assigning this 100,000. I'm assigning this 100,000 to self dot balance, another variable, but inside this account, inside this accounts class. So because of this self, and we know this self, it belongs to the accounts class over here, I can call self in everywhere. So as you can see here, I don't need to add balance over here. But when I did self.balance, it quickly called it from this init method, and added the amount I wanted to add over here, which is 50. So that was 5,000, and gave me a new balance of 105,000 Ghana cedis. Should I take it again, or do you have any questions up to this point? So I can take it again before I move on. Yeah, Mr. Andrew.
Yeah, please, I want to find out, does that mean that in this case, there are not more than one attribute, or all the attributes have the same, let's say, class
Yeah, come
account?
again. Can you repeat again? My mic was muted. Sorry.
All right. I want to find out, does that mean that in this case, there are not more than one attribute, or does that mean that all the attributes, let's say if we have, let's say, John, Kweku, or other people's account, all of them have the same, let's say, class account balance?
No, okay. So this is the
Because you said
instance
here,
of
it means that we are retaining, or that, let's say, the 100,000 from the class account when you
yeah,
use the init.
yeah, exactly.
Yeah.
So I think before I said this self belongs to the class, right? And this class is equal to the objects that you are calling it. So this is John's account. So currently we're working with John's account. So let's use someone else's account. Let's use Mr. Gabriel's account. Mr. Gabriel. So no, it's Mr. Andrew. Mr. Andrew is the one who asked the question. So let's say Mr. Andrew. Yeah. Mr. Andrew has 100,000, right? If I deposit 7,000 over here, I'll do Mr. Andrew. In this case, I am depositing it for Mr. Andrew. So Mr. Andrew in this case is here. So when I print Mr. Andrew here, I get 207,000, right? Get 207,000 over here because, like I said, cell belongs to the class, right? And this class belongs to the object. So the object is an instance. So it picks, okay, whose account am I depositing the money to? So is it John's or is it Mr. Andrews? So since I've created two objects or two instances over here right now, it picks, okay, so self is for account and account belongs to this object. So this objects right now, I'm picking Mr. John's money. So let me print Mr. John's account too so that you see the difference. So John. But you Andrew, yeah. So as you can see over here, this is taking Mr. John's dot deposit. So it's taking John's class or John's object and it's depositing the money to this amount of money that John has. So this particular one, yeah. So in this case, this cell.init doesn't affect the objects. It affects what's happening inside the class. So it's passing whatever value you are given from this object or from whatever you're passing over here, since it needs a balance here, right? It's passing that throughout everything in that particular class. So if in this case, Mr. John had 100,000, to pass this 100,000 to self.balance, and this self.balance would be able to perform whatever on this 100,000. The same way if I had another instance of Mr. Andrew, and I said, okay, so Mr. Andrew has 200,000. So Andy is depositing. It's now pick, okay, which self am I talking about? I'm talking about Mr. Andrew's account over here. So I am depositing. So it now replaces this balance with Mr. Andrew, his 200,000 over here, and and deposit 7,000 over here. So the init only affects stuff it only affects whatever is going on inside the class. Do you get it? So all I did was just add this so that when I'm defining any of someone's account, I wouldn't need to be inputting your account. Imagine if you went to the ATM, or imagine, yeah, and I check my balance. My balance is 100,000, right? And I'm depositing, but I have to input 100,000 again, and I'll add the amount of money I'm depositing. See, that is annoying because the system already knows the amount I have. So why is it letting me input it again? If I want to withdraw, that was this case over here. If I want to withdraw, why is it that I have to add the current balance again, which is maybe the after depositing, that's 100,050, and I'll have to withdraw 30. It's going to be, I won't actually work. I won't go to that bank. I won't sign accounts in that bank because it's really annoying where I have to be inputting my amount and my withdrawing amount all the time, because the system already knows the amount. But in this case, I don't need to input the amount anymore. The system knows that, okay, John has 100,000. So when I'm depositing, I'm just depositing this money and adding it to the 100,000 over here. Mr. Andrew also has 200,000. When I'm depositing 7,000, it's adding it to the 7,000 over here. So how is that working? So with the init function over here, whatever parameter the init function gives you, you can decide not to depend. That's even dependent if maybe you are maybe let's just say there was a case where everybody has the same amount of money. Because it's that one, that's the difference. That one you don't need to add any parameter over here, and I can just say balance is equal to 100,000. So in this case, you can say everybody now would have 100,000 initially. So that is, there will be nothing. There wouldn't be anything even here. There won't be anything here. There will be nothing here. So there'll be something here, but there'll be nothing here because I have hard coded that everybody must have a 10,000 inside this particular account. And in that case, even if I call Mr. Andrew, I call and I instantiate or create objects to 100,000 different accounts, they'll all have this amount of money. That's because I have hard coded it inside. So in that case, in Mr. Andrew, in the case where you were talking about, doesn't mean that everybody will have the same amount of money. In this case, if there's no parameter that says, okay, how much do you have? Or how much does Mr. This person have? For the bank teller to input it and say, okay, everybody by default will have this amount of money. No matter who I call, I'll just be adding to this amount. But in this case, everybody has its own unique account and would have its own amount of balance, like his own amount in his own account. So in this case, I would that is why I put a parameter here so that I will know how much Mr. Andrew has and how much Mr. John also has.
Okay.
Is that did I try go over again, or that's clear?
No.
That's clear. Okay.
Oh, I think I get it. I get it. I was actually coming to ask what you just explained, that assuming, let's say, the self balance, we have a fixed value there for everyone.
Oh, okay.
Just as you have explained.
Yeah.
So I think I get that part.
Okay. I think we'll have this. I'll have this. There's this fun exercise. I think it's still there, where there'll be an instance where you actually just give it, okay, self dot maybe something, and you would give it a hard coded figure. Yes, and you see how we can do maybe both of them. How we can self, yeah, how we can use both of them. So in this case, you can see that we are accepting how much he has. So that is the beautiful thing about the init function. So these magic methods, there are lots. As you can see, the main, someone said let's talk about main. Yeah, the main, this is a wrapper function, it's a string function. I'll talk about these ones. But before I talk about this, let me talk about main over here. It's not compulsory to do this, but I did this so that you know, because most of the time when you're sharing code, most people like to do this. I could have easily done this as well. I'd have kept everything here. And if I comment out everything, okay. Now you guys know that when we comment something, Python is not going to use it. And I print, I also get the same answer. But why do we use, so what does this mean? Realize that when we were looking at the memory location, it was saying account main, this main. So let's put it in a scenario where, yeah, let's put it in a scenario where we learned about importing. So Steven imported math last time. So I'm importing math, right? If I do name, this name is a magic method. So if I do print math, yeah, you don't really, and I do print name. I say this is current project. In the comments. And I say this is the math library. Library. Yeah. If I run this, watch something. So I said, what is the name of this? It's called math. And the current project, the name is called main. So in this case, I imported a module or a library. So I said a library called math, right? So the name of this library is math. The name of the file of this library is math. Because it's math. So if main is equal to math over here, if I had imported like math and I wanted to do only math function, if I wanted to write a code that would do only math things over here, and I did main is equal to math, and I executed some stuff, it may not have worked. It would only perform things that have to do with math. But in this case, I am performing what I'm doing is I am what we are working on is this main project. This current project we are in, this current Jupyter file is called main. Anytime you're writing a project and you create a new Python file, that Python file you're working inside is called main. So anytime you are even seeing memory locations and you see main, it means it's a current file you're working with, because there are a lot of occasions where you'll be importing a lot of modules. You import NumPy, you import pandas. Don't worry about all this. You import a lot of things. But in this case, they are saying if name is equal to main, that is if name is equal to main, that is if the name, that's so this is like a boolean. If the name of this particular project we are working on is equal to main, perform everything that is in the main folder. That is, so what you are working on here is the main folder. So perform everything that is in this main folder. That's just what this main means. So this main is the name of this current folder, which is the oops in Python, this current folder. And this math is the name of this math library. So in most times when you are working with functions, even functions, yes, they are working with classes. You see people doing this. It just means that they are given a condition to tell you that if the name of this folder is equal to main, perform the functions which are inside this main folder. Because maybe you may be doing something which is inside another library, inside another folder. Like the way you can create another, sometimes you can create another Python file and you call that Python file inside this current library, this current folder you're working in. If you call it like that, that's Python file you've called. It's not the main, the main the main folder, sorry, the main file, the main Python file. So it may not perform certain functions, or maybe if there are certain errors, it may skip it. But when you are using main over here, it will perform everything that is in this main folder. If there's anything in this main file, sorry, file, not folder, this main file, this main Python file is going to make sure that it's going to perform these functions. But and you can also, like I said, you can do it without it. But I just want to show you that this is something that's mostly conventions. You see people doing this. Don't be worried. It's the same thing. This is just after Python this convention, you can write whatever you're writing. Like you can the same way you can take this and put it over here. If someone has, if somebody has more information about this main that I've been covered, please feel free to say it. But basically, that's what the main does. And I can run this everything here. That was the main. It will still run. maybe to put into consideration other libraries as well. But so the main is also help. It helps. It's I'll get more information on the main and how why most people use it. But I know in conventions most of the time, you see people using this, and it's nothing special. It's just that they are just saying, okay, if the name of this particular file is main, then if you're on this particular main file, do this particular functions for me. Yeah. And even and also for example, like if I was supposed to call this, in case I had another file called maybe savings account, right? But it's not in this particular Python file. Only this one, if I call that class, then I'll import it. So I can import this and give it into, I can send it, I can call that particular this file into the savings account Python file. If I run it, it won't run this because it's the Python file that I am calling is it's not this account file currently. It will be that's a different file. So it won't call any of this. But when this is outside it and I run it, to run everything, it will run all these things that I'm running inside the other file. And there are cases where you don't need this. Maybe just want the methods inside, you may not need this, and you would have to put and then to just call it either way. Yeah, Mr. Isaac.
So, with my understanding, for example, I've been seeing on GitHub that, of course, people write it using the same convention, the if name, double equal to side, and the main. So sometimes if you want to, let's say, pick some of the line of codes or maybe run their code in your Colab or something, then I realized that you have a lot of errors. Would that be the reason?
When they have this.
Yes.
When they have. Okay, well, honestly, I won't say this particular is the reason because it may depend. Maybe the particular GitHub you are using, the particular code you are using, maybe you are not having certain libraries or certain requirements that the code needs. So they are actually, unless I know the type of error you are getting, maybe they may this may hit an error. I haven't really had taken a code from Colab, I mean from GitHub, and had an error pertaining this particular issue. So sorry for my
Mostly
ignorance.
when I'm dealing with some data sets, for example,
Yeah.
if I'm doing some data sets, let's say you are working with some medical images, you want to pull some data sets from somewhere. I believe, well, for the explanation, either I don't have their data set, and that's how I'm getting that. But again, if I still want to run their code with my data sets, somehow I get these errors.
Oh, okay. So do you edit their code, or like you have your own separate file and you're calling that like that code in your file, like you're importing their code into your
I'm
library?
importing, so I'm basically lifting every line of code they have there into my
Yeah.
and run it there.
Oh, okay. I don't think you're supposed to get an error because normally if it's running everything, it won't run this at that moment because I'm not using I'm not using my right. I wanted to create another file and I'll do an example, but it would be quite complicated using Colab unless I do it in my local file, and I don't want to confuse you guys.
I will contact
So
you on it.
yeah, okay. So normally, if you have mostly you can like this particular file I've created, I can create another file, Python file, and I'll say okay. I am importing. I want to use all these libraries, all these modules, all these modules and classes inside this particular file, right? Maybe in this particular file, I have some computation that I'm working on that I don't want it to be applied to the other file that I am importing these libraries on. So because this is not equal to this particular name, this file name is equal to this main, it won't perform this particular function. That's how I understand this. But I'll get more understanding for you people if you need this. But conventionally, you see people writing this and it's nothing scary. It's the same thing you still write your code the same way you write it when main is not there. So if it's not a big code like what you are working on, you can just copy all this and write it here. It won't, but it shouldn't be indented because yeah, and it will still work just fine unless there's a reason for you to use it. But I just introduced it for you to know why for you to know that you will see this more often than usual, but it's nothing scary. But I'll look for something. I'll look if there's any errors or anything that you need to look out for when you're using this. I would make sure by next course I would let you know. So we are done with that special function. But there was something I wanted to do and I think I couldn't do it. So let me show you what I wanted to do. So we know that accounts is 100, right? Normally this is the back end. If I say back end, maybe this is maybe is the teller who would know who would when initially you are depositing you are depositing an account or you are placing an account initially, sorry. The seller will ask you how much do you want to deposit. You give the person 100,000, he counts and the teller inputs 100,000. Right. Now let's say you go into your ATM and you want to check how much you have. So now if I do print John, right? So yeah, so John's dot balance. Let me comment out this. Let me comment out all this. I don't think I need this right now. Okay, yeah, it worked. So see, if I did sorry, if I did John dot balance over here, right? Normally you realize we call methods most of the time. But this case, I was able to call this self, which is very weird. Most people would understand. Yeah, that's the power of this init method. It's a constructor. It's like a global variable. When it's a global variable, it's something that Python will always look at before it looks at the rest. So no matter what, it's always something that is there. So I'm calling it like the way I'm just calling a normal method, but without any curly braces, and I'm seeing the amount of money. Sometimes we have something called a representation method, where maybe sometimes let's say John, if I was just supposed to call John, sorry, you would see that it's just giving me a memory location. Just giving me a memory location, nothing else. And maybe for representation for the upper function, most of the time, let me run it and you see why we use upper functions most of the time. So I'm calling this, if I just call John again, saying accounts 1,000. It's no longer, it didn't give you the memory location, but I just gave you this. Why did it give you this? Mostly this is used in the back end as well to just check your mostly what this does why most people use this is just to check certain things. Maybe when they are running it and they want to know this amounts you have over here, maybe down the code down, maybe because they're writing a long code, they want to just know the print this repair function over here represents this balance, this class called John. Sorry, this class account, and it's giving. And I've passed it. I mean, we know. I think we know F strings. So since we know F strings, I'm just saying account. That's this account over here, and I'm giving the balance. That's the 1,000 over here. And mostly when people are using repair functions, they just more duplicate how the convention that they have given. Just like this, they duplicate it just to know what they are working with. So sometimes if it's a list or if it's a dictionary, you see that when they will duplicate it in the form of the dictionary that they did, it's just to check what they are doing. It's just to represent the memory allocated space. So if I, without the wrapper function, you could see that just gave you the memory space if you run it. Yeah, this is the memory space. So we are representing this memory space as what we are seeing over here. So wrapper function mostly just used at the back end, not in the front end. You can use strings, but strings on the other hand, which is the same which has the same thing as a representation function over here. But what strings normally does is that what displays in the front end most of the time just shows what the client is doing, what the user is doing. So if I want to check my balance right now and I don't do anything, I just call John. Says your current balance is no, it's supposed to be your current balance is 10,000. Here is 10,000. Your current balance is 10,000. Now there's a confusion because initially when it was only paper function, we just got balance. But now we're not even getting this argument anymore. We're just getting this straight. Yeah, why is that? The reason is, like I said, this is normally used in the back end just for you to check out stuff. This normally is like, or this like a go-to. So this normally is what executes first. This has more priority than this. So when the Danda string is not there, and you see it under RIP rep function rep R method, this would execute. But in cases where there's an error or something that goes on here, this will execute. But this would always execute first because this is what is being displayed. This is just for like you to check out stuff in your back end. So in case maybe there's any issue going on here, this is like a backup that would run. So each magic method, as you are seeing, have its own specific. I won't talk about a lot of magic methods, but this is something that maybe I don't normally use this a lot, but maybe in case you just need to check out something or you are building an application in this case, maybe this is something that you would be using. So I'm just introducing you to these two. So this particular for wrapper functions, and this particular for magic methods. So we know init function. What the init method does, not function. What the init method does is when there is going to be a global variable, and it's a variable, when it's going to be a global variable that's going to be used across everywhere, then we initialize it in the init method. So you can have multiple methods over here. And the wrapper function is when you call one, this you can decide to, in case you want to represent it, in case I had another thing called maybe interest of say 5. I could have said, okay, account is this. I've said this and it's interest of self dot interest. So you can do a multiple. So see with interest of self of interest of 5. So it's just to represent what is going on in this init function. So the same thing that goes on in the wrapper function. You can also do the same thing over here, and it will work perfectly. So this wrapper function is just to have a good representation of the memory, that memory output that gave us, just giving us that good representation of whatever is going on. So I can do balance and I can do interest, and it will show me everything I need to see or whatever I want to see that is inside this particular method. That's what our wrapper and string does. But string has more, the str has more priority compared to this. So if there is no string, you can use this. So depending on what you are doing, you can use any of these two. So I think I have covered magic methods. Does anyone have any questions concerning magic methods or how they want to use it? Before I move on to inheritance, that's the last thing we are doing, inheritance. And after inheritance, we are moving on from there. For after inheritance, we're just doing examples, just to help us get back to know what, to get to do. I mean, we do more examples on Python so that we get used to the Python syntax. So please let me know if you can give me a thumbs up or a thumbs down if you don't understand the magic methods. So I'll move on, or if there's anything I should explain. I'm not seeing any thumbs up or thumbs down. So please, can I move on? Okay, thumbs up from Daniel. Okay. So I'm moving on. That's how magic methods are. That's how they work. Yeah.
We'll take a short break.
Oh yeah, yes. Yeah, a short break. Then we'll just go through quickly about inheritance, and we'll just do an example. We'll just do examples from there.
Yes. So we go on 10-minute break. We come back at 12:10.
Okay, so we have just one more. I'm not going to take you through the deeper parts of classes for now. I think what we are working on is something that I'm only tackling the things that we would normally be using. Maybe as time is going on, we are doing more advanced stuff. Maybe in the level 2, maybe that's when I'll start talking about maybe maybe I'll just be adding maybe 1 or 2 advanced math properties or static methods and stuff. But currently we don't need that, so I won't add that. The only thing now that is left is inheritance, and I think that one is also something that's even in machine learning in particular. I realize I've been using that a lot, especially when you are working with frameworks and data type and trying to create certain data sets. You would inherit from certain custom data set classes, and you would be using them in your classes. So what is inheritance? So let's put it in this case where I was saying we had the analogy of a kitchen where we had labels, containers, which were the methods, right, for the spices. So the class is the kitchen. Maybe we have the bedroom, which also has its own containers where you put your shirts and your trousers, and you have certain containers. But maybe you will need to go and you need they are totally different things. Maybe they're all in one house, so it's like it may be similar, and you may need to take your broom. Maybe when you go and take your broom is in your kitchen, right? You mean to go and take your broom for your kitchen. You have to go to the kitchen to go and take your broom. So in this case, you have to enter the kitchen class to take your broom. Although you're in the same house, but in totally different spaces, right? Totally different classes. That's something that inheritance is. It allows you to create a subclass from a main class from a class that you've already created, and use everything that is inside this class you are seeing, everything that's inside this class. You can use everything inside this class inside another class. That's the beautiful thing about inheritance. So let me just read this and I'll explain it to you. So inheritance is a fundamental concept in object-oriented programming that allows new classes called subclasses or derived classes to inherit attributes and methods from existing classes. So um, this will be called the parents class in this case, and it enables you to create a hierarchy of classes or share with shared characteristics and functionalities. So, like I said, it enables you to create a hierarchy of classes with shared characteristics and functionalities. So you can have multiple classes and you can inherit, and each class can inherit each other, depending on what project you are working on. If it's a large scale project, but right now I'm just working on a bank statement, a bank account. So in this case, with this example or this explanation I've given about inheritance, which allows us to, in this case, I have another class called savings account, right? So this is my normal account, but I want to have a savings account. And this savings account gives me some interest every month, or some amount of gives me a particular interest. So when I go to my savings account, I get to see the amount with the interest. So it's also in my bank's account. It's also in a bank. So I need instead of me adding it to this class to make everything maybe quite bulky, and which is not fully related to it, but it's related to it, but not fully. I can, please, if I'm speaking too fast, let me know. I would slow down. Uh, I would, I would need to, in order to create this savings account, I would need to have maybe certain features such as maybe my current balance, or when I add, maybe the savings account needs to know when I add. Let me delete this. When I add money, when I deposit money and my new balance is pops up, I need to know how much, and I need to calculate my interest. You get me? So in this case, my savings account is another class, and I'm inheriting. And how do you inherit from another class? Very simple. The curly braces that you are seeing, initially here there was no I'm sorry, there's no bracket. Open parenthesis. Sorry, I keep on mixing it. There is no parenthesis over here. But in order to create a class, in order to inherit from a class, all you have to do is have a parenthesis and put in the class name inside. That's it. You have inherited from the class. You have inherited everything you need over here from this class. So now you can even leave this class and be working here, depending on what you're doing. So if I need to get my initial balance or the balance I had, I don't need to write. I don't need to now give a value over here and now come and give a value over here again. I can just give it one value and I can derive it throughout everything, and it can also be assigned to this. So that is the beautiful thing about classes. So I think even in our daily in our accounts, when we have our bank apps, we can realize that when we are saving or we have other sections in it, we still have certain information from another section that is applying into another section in our bank in our apps. That is basically how the inheritance works. We can derive information and other things from another class simply by just inheriting from it without having to write all this code again here just to call it again. That will also bring redundancy and clear a messy code. So in order to inherit, we just call the class we want to inherit from. So we can have multiple classes to inherit from. So if case you had another class, we could have just done a comma and we call another class. But right now we have only the account class, and so we're inheriting from this class. Um, do from this do we understand the point of this currently? Can I move on? We know what inheritance is, like the concept of inheritance. Okay, thank you. So with this said, we know. Come in.
Hello.
Yeah. Precisely.
Yeah, please, can you go over the concept of the inheritance once again, please?
Inheritance. Okay. Yes. So Mr. Andrew.
Yes,
So,
boss.
let's say you put your, let me use the kitchen analogy. Let's say you put your broom in your kitchen, right? Maybe in your storeroom in the kitchen after you sweep, right? And you're in the
Okay.
bedroom. Yeah. So let's say the kitchen is your class and you have a method called broom, which sweeps. And you have a method called spices and other methods in your kitchen, and you're in the bedroom, right? And your bedroom to have your own methods, such as your cabinet to put your clothes and your shirt to put your
Mm,
maybe to put, you have your laptop in your bedroom and everything good. And yeah, you want to sweep your bedroom. What do?
mm,
Go to the kitchen class,
Kitchen. Yeah.
and you go and take your broom to sweep in
Okay.
your bed. So you take the broom, which is in the kitchen initially, but you bring it to your bedroom to sweep.
Okay.
That is something about inheritance. So what happens is, and even the funny thing, although you've entered the kitchen, right? So you had options to even take the spice. If it was spices you needed, you could have taken spices. You could have taken any other thing because you are in the kitchen right now. You have
Mm,
access to everything in the kitchen. Yeah, but you just decided to take only the broom because that is what you need. Maybe you may need other things as well. So when you are going, you can just pick those things as well. That is the concept of inheritance. So the inheritance basically is having another class, and with that class, you are inheriting from and the maybe you have two classes, right? You've created another class. That in this case is savings. And by you are inheriting, when you say inheriting, you need maybe certain functionalities or certain features or arguments in the your bank account class, such as your
mhm,
current balance. Because in your savings, when you're doing a savings accounts, you have interest and interest rates attached to it every month. So I know this is not practical. Mostly, yeah, just they ask you whether it's savings or current. But I just said accounts and savings. But let's just go with this. So in your savings, you have it's mostly you have some certain interest and stuff, but you need to know your current balance in order to um perform the interest, in order for the system to know the kind of interest to give you, right? But we know that the balance is over here. It's in this particular account, as we can see over here. And we won't want to now create another class again called balance and now have to give it 10,000 again. I mean, it's one system, it's one big system. We are creating a bank statement, one big bank account. So we don't have to be always like using the analogy of the ATM where I said when you want to check your balance, you go to balance, you see that okay, your balance is 10,000. Then you go to withdrawal and they ask you to input your balance again and the amount you need to withdraw. That is like redundant because the system already knows the amount you have. So why does it
mm,
want me to put my balance again? It won't make sense. I won't even use that bank, that bank. So what happens is I um the system goes to pick the initial balance that you already have over here. Okay, so that's the current balance you have. That's the current balance you have over here. I created another method over here called balance to not confuse everybody. So this balance returns self.balance. That's the current balance you have. So it just goes to pick the current balance you have all the way here in this account and adds the interest rate. If it's 5% interest you want, maybe that's 5% they're giving you, then it adds 5% interest to this, and you are done. So you don't need to now write the 10,000 again when you are using the savings or when you are using both of them. You don't need to do that. You just do that once and you are done. So that's the beauty about inheritance. You are able to use another class's stuff easily in your class without having to redefine it again. Does that make sense? Am I making any progress?
Yeah, you are.
Yeah.
Yes.
So yeah. So in order not to
Yeah, it's
redefine
just
it,
that if you could repeat the operation again,
come again.
it's very clear. The concept is clear. But if you
Okay.
could repeat the process again.
The process. Okay, in terms of the code or the.
Yeah, yeah, yeah.
Oh yeah. Okay. So the question is, how do we inherit from another class? As you can see, we have a class called. I think let me just put this in another. Let me put this here. So I'll stop scrolling too much. Yes. Good. If I do this, you can see. Okay. So we have the class over here. So in this case, you have a class called account. So how do we inherit from this class? Given this savings account, we pick the syntax in inheriting is just to put a parenthesis and you'd give it accounts. That's the name of the class over here. So if you in order to inherit from a class, you just pass it the class name. Anytime you want to inherit from a class, you can pass it the class name. And you can even pass, and there are cases where you have multiple classes if you're doing a big project. You can pass in all those classes, those class names. You can inherit it. You can inherit a lot of multiple classes in just one class, and it doesn't matter. You can perform your functions as you are going to do. So in order to inherit, the only way, the simplest way, or the only way to inherit is just to put a parenthesis and call the class or initialize it with a class name, the class you want to inherit name. In this case, you want to inherit the main account class over here. That is what we are inheriting over here. So we're inheriting its methods, all its methods over here. I can even call, I can do, let me, I'll comment out everything here for now. Let me leave this. So I can do, I say self. I want to do another performer. I want to withdraw. Okay, so let's say BF withdraw, no deposit. Again, I don't want to call this. Let me just do this. I do self dot deposit is equal to deposit is equal to, no, let me just print it. Let me print self dot deposit, right? Work. Let me do a self dot get balance rather. Self dot get balance for now. I don't want to confuse. Yeah, self dot get balance. And if I print this, it should work. Yeah. You see, when I did a self dot get balance, I got 1,000 over here. Let me comment out all this. Yeah, so if I'm talking about, see, so I got a balance of 1,000 over here. You forget this for the meantime. But when I did a self dot gets balance, print self dot get balance inside this. But get balance is here. It's over here, as you can see. But because I inherited it from this particular class, I was able to just call it like it was part of it was a code I'm already using without any problem. And yes, also if I want to, let's say, inherit a method from another method, so I want to call a method in another method, I'll just do a self dot. In case I wanted to, let's say, I want to use the deposit method over here, which I won't use, but I can do a self dot deposit over here, and I'll just return this over here. So I can, in case I was having any computation with deposits, I can do it over here. So that's how you call another method inside another method. Self does the name of the method. So with that, so that's the same thing I just did over here. So I called it self does get balance as if I was already, I was calling it in this class, if I was already in this accounts class and I'm calling it. That is how when you inherit, you can easily work with these things. I can call self dot withdraw. So if I do a self dot deposits, deposit, I'll have to give it I'll give it a balance of amount of 5,000. Yeah, I print that. Yeah, I got 6,000 because over here I had 1,000 over here. I'll come to the code back. I had 1,000 over here. This is the interest rate that is here. This is interest rate. But I'll explain it soon. But I want you to understand something. So when I did 1,000, so I here initially just had 1,000. I didn't have to call it 1,000 over here. And call this here in order to use it. it just automatically knew that when I just called it here, it assigned it to this balance over here. And when I called self.deposits, it just called this 1,000 and added the amount that I kept over here, 5,000 over here. So I'm calling it casually, like the way I would have just called it inside my method. So there's nothing special that you would do. Okay, there's one special thing, but I'll explain it to you. But there's nothing special or too special that you'll be doing when you inherit. When you inherit, you can work with any other class like you're working on it as if you are in that same class, because I could have easily done the same thing over here and said return balance. If I return balance over here, solve the balance over here, let's balance over here, I would have returned solve the balance. So if I did, but either you can't do a method and int to work. But if I just call it over here without any addition, it will return this for me, get balance. Same thing that I did over here. So I hope you get it. When you're calling from one method, when you're calling from another class, sorry, you call it as if you are already in that class. You can just call, although you're in a different class, you can just call it as if you're already in that class, and this will work for you perfectly. That's the beauty of inheritance. I don't have to do anything extraordinary. The moment I just put the class name over here that I want to inherit from, I'll just call any other method or any attributes that the init has easily without any problems. So let's use the savings account as an example. So I want to have a savings account, right? Aside the normal account I have so that I can have some interests as time goes on, right? So I call the df function, the init method, init method. And with the init method, I initialize balance is equal to 0. I can take it out. But just for yeah, also sorry, can I go back? I'm very sorry. Let me go back and explain one thing before I move on. There is one more statement I didn't explain that is also very useful in classes. It's called asset. Asset. This method. And asset is very good. Remember when you were dealing in functions, Steven said something like, in case you want to return a string, you can say str. Yes, or you want to return an int. Let the person know it's an ntr. You want to take an input. int, sorry. So the more advanced version is an asset. What asset does is it checks to see if the condition you are given is correct. If it's correct, then move on. If it's not correct, stay. So let me use this because I don't want to mess up the other code. So in this case, we are supposed to accept integers, right? Which are numbers. And in this case, you can even do floats because maybe in case there are some coins we want to add, but let's just use integers for now. We're going to accept integers, right? I will say accept. I just call the statement like I'm just calling a normal statement. Accept. This is instance is one of the Python methods where it checks if something is an instance of something. That is, for example, if the number I'm putting is an integer. Is it an instance of an integer class or is it an instance of a string class? I can have a list and I can say, okay, is one an instance of the list I have. So if I have maybe a list of lists, yeah, 1, 2, 3, and I use the instance on this and say it's with 1, and I give it 1 over here. To return me true because 1 is an instance in this list. So that's what instance does. Just check to see if there's something. If it's not, then give you false. And if it's giving you false, what do you want to tell you? That's what its instance is. But I won't get too much on this because I'm just trying to explain what asset is. We would explain more of this in the future Python.
So if I understand,
yeah,
it's like
The asset is to ascertain the validity of something.
yeah, exactly. Yes, it's to valid. Yes, it's to valid. It's to make something, but check its validity. So if it's valid, move on. If it's not valid, stop. Don't even execute the code. Just stop. So let's say in this case, I'm saying that okay, asset is instance of balance. What I'm trying to say that asset if don't check the validity of balance if it's an integer. If it's true, move on. So if it's an integer and I run everything like this, balance of interest. Oh, okay. Let me take this out. I think I have commented it out already. So yeah, it should work now. Yeah, so we realize everything ran perfectly, nothing, because I inputted an integer over here. But what happens if I put a string? Let's just try and put a string. What happens if I say, okay, I say 100 instead of me putting the value, I say 100 and I set. I get a particular error called assertion error. I think we have to do, we'll talk about error handling too. Assertion error. That is a particular error that we got because of this asset. And what is it saying? Assertion error. It should be a sorry. Let me change this. It should be an integer. Yeah. If I want asset, it should say asset error. It's so a spelling error, but it should be an integer. It is telling you that the value you kept over here in 100, this value, as you can see, is pointing to John, the account that you kept here, 100, is saying that it should be an integer. It shouldn't be a string. So this is a the what I just kept here is optional. It helps the user clarify what he's doing. Because if I run this like this, I just get an assertion error. I don't really get any additional information that tells me why it's giving me that error. So most of the time, we just add maybe a particular condition that helps the user know why he's getting that error. So in case he decides to use 100, it says, oh no, it should be an integer. So just okay, now he knows it's supposed to be an integer, so he now converts it to 1,000 cedis, but we should have used floats. But
Okay, I think I get a concept, but
yeah,
the only challenge is how to run the operation. How do
the
we,
asset operation.
yes, how do we,
Oh,
how do we write the code? What
okay.
comes first?
Okay. So the code, what comes first is assets. You call it like a statement, like the way you call DF, call assets. When you call assets, then you can now check. So it's this not how it depends on what you are doing. So I could have said, okay, asset if maybe for example balance is equal to 1,000. I think, yeah. Let me try this. Right. So it depends on the operation you are doing. If it's not 1,000, I think it should give me an error. Yeah. 10,000 should give me an error. Yeah, assertion error. So I can say, okay, assertion error. Balance should be above 10,000. No, if it's equal to or greater than, yeah. So balance, I can see. Oh, sorry. If it's, yeah, like this. I can see over here that balance should be more than 10,000 over here. When I do this, I get that session error because I'm putting only 1,000 here, which will tell me that balance should be more than 10,000. So it depends on what you want to tell it. So it depends on the condition you want to check. So if right now we want to read the account that we are trying to create, say premium account, which you can't have a balance less than 10,000. You can use this kind of assets, and you start with assets, and you give it a condition that okay, balance greater than 10,000. Or in this case, I said instance. I want to check if it's an instance of an int. If it's not an int, if it's not an instance of an int, then it should be wrong. It's told me that it should give me an error. So if I put 10,000 over here, or let's say 11,000 over here, I'm not supposed to get an assertion error. Everything is running. So asset is just used to end it before anything happens. Before it even goes through this other code, it just stops at this point. It assesses it and say, okay, is the condition I'm doing true? If it's true, fine, then let's move on. If it's not moving on, then give me an error. So the format is assets and the condition you want to give, and this is like the basic Python conditions you'll be given. So greater than, or is asset equals to this, or is asset equal to a particular value. If it's equals to that particular value, tell me this. If it's not equals to this particular string, or is it an instance of, because it's instance, is that an instance of a string, or is that an instance of a list or something? If it is, then give me this error. So assets is that straightforward. You call it assets and you just give it the condition you need to give it. And it checks that condition. If the condition is true, it moves on. If the condition is false, then it gives you the error that you have given it over here. And in order to give it that error, all you have to do is put a comma and put the rest into quotation marks like this. And you work. You can also do formatted strings with it. So assertion should be greater than maybe 1,000, 10,000, but add balance. So the balance is the current balance you kept. So if I did 1,000 like this, it said a session should be more than 10,000, but had 1,000. So you can customize the error so that the person will know how much he inputted and how much is expected for him to input. So that's how a session works. You give it a set statement, you give it a condition, and you give it the error is optional, but I recommend you do that. You give it the error or what the person is supposed to do. You can write it in the formatted string. You can perform whatever you want to perform with the banner with the comments to make it more clear for the person.
Okay, could you explain to us what the formatted string means and how you did that? You just brought
okay.
F.
Yeah, I think Steven explained it. That's why I didn't. But let me explain. Let me explain quickly what a formatted string is. So a formatted string, normally, if you are writing a string, let's say I have a value of 5, right? And I want to print maybe my value is, I don't want to say 5 because if I do, I can do my value is 5 over here. But what happens if I change this to 6? It says my value is 5. So formatted string is a way of allowing you to input other variables inside a string. Because normally when I put in a string and I even say A over here, it will be wrong. It will just give me A. But this is a string. There's nothing you can do. But adding a formatted string, that is the F over here. The syntax of formatted string is put an F. When you put an F, what the value you want to put, you put that value in curly braces. When you put that value in curly braces, it now sees this, although it's inside a string. You can see that it's inside a string. There's 2 quotation marks there. There are 2 comments. What's it called? What's the name? Yeah, it's wrapped around this, and you can see that it doesn't see this as a string anymore. It doesn't see this as a string anymore. It sees it as a value. So when I run this, it tells me my value is 6. If I change it to 7, it's my value is 7. So formatted strings are a way of combining a string, a normal string, and variables together to make to form a sentence or to make or to give clarity to what you are doing. Basically, in case sometimes you want to add a particular string and associate it to something, but sometimes you see me doing this. Maybe you see me doing is this, and outside the string I do a comma and I put an A. It's also accepted. Also accepted. This is also accepted. It's not wrong. But sometimes you would want to put it in between stuff. Maybe I have a B which is equal to 8 or 9. I can, and I'll say, okay, my first value. This the best way most like formatted strings is when I need to put things in between a string. I can say my first value is, then I do A, right? And my second value is, and I do a B. So in this case, it's easier than to now put it at the end and do this because I'm putting it here and I get it easily. But the old convention of Python was quite, you have to put a particular code here and particular code here to represent it, and that one was more long. But with formatted strings, it makes it way easier to mix values with a string. That's why it's called a formatted string. Mr. Ivan, is it clear? Is it clear to anyone else?
Yes, please.
Okay. We'll talk about if it's still a problem when we are going back in Python. We'll talk more about it. We'll do more examples for us to get it. So talking about, let's go back to the savings account. So now that I have called the account over here, right? Now I need to create a savings account. So I need my initial balance. Because that's the balance that is over here. The initial balance I need is the one I need over here. How much I currently have, and the interest rate I need. For now, let me just do it 0, but you can do it 5. And okay, so basically the minimum is 5. I can try to update it if I want to in the back end. So currently the interest rate is 5. Now there's something here which is also different from any other class code you've seen, called super init. Now what is super init? Super init is very convenient, something which is very convenient for classes. Just doing super in curly braces like this and adding this init statements just beside it. What it does is it calls, since I am inheriting from this account over here, right? Like I said, this initialization method is a global method. It's something that cuts across everywhere. So the super init, what I've done is right now is I am taking this super init, everything that is here, the values that are here, I'm picking it so that I would use that values in my code. So if here in super init I say here is 1,000, that means here to be 1,000. Because I don't need to write another code here again. I just define it here by say super init, and I give, sorry, the other way around. I give the value of this one to the value of this. So when I want to check my balance, it's easy. I can't just I don't need to input it twice. When I just input the balance over here, it knows that the initial balance is 1,000 over here. So that's what super init does. It checks the initial balance. Sorry, it checks it goes whatever, it checks this particular init function of the previous class you've created. And if there's a value here that you want to replace, you just call super.init and you pass it the value. So it gives that value to the balance over here. And now you don't have to do any other thing. You can perform you can just call all these stuff inside here without even touching here anymore. Because initially you've assigned a balance here. So initially, so without the super init, you'd have probably caused an error that you needed some parameters over here to need a parameter, the balance over here to perform these functions, and you are not being able to do that. In certain cases, you may get some errors. So with super init, it's not doing that. So the 1,000 I've kept over here is the initial balance. That's 1,000 over here. And this initial balance, I'm assigning it to the super init. And with this super init means that, or this super init is referring to this initialization function over here. Since it's only one, if it was two, I could have said, okay, yeah, I'm assigning two variables to it. I can choose to assign only one, depending on what I want to work with. So in this case, we need only the balance. So super init, we'll do some examples with super init. Maybe you would understand in due time, but just know that super init allows you to pick, it allows you to assign a variable to the other class, and which allows you to perform every other thing that this variable needs. So here we need a self.balance, we need a self.balance, we need a self.balance. So since we've already assigned it here, we can call anything here without assigning it here again, because automatically the super init assigns it for us over here, and we just perform any other functions we want to perform, or any other operations we want to perform without any problems. Do you get what the super init is?
If you could go over it again.
Okay, no problem. So, like I said, in the savings account, right, we need to in order to know the interest we need to give, or we need to know the interest rate, the amounts of the interest, we need to know the amounts we have with the interest rate, and we do the calculation over here to get the interest. Said my voice keeps breaking. Is my voice breaking? Please tell us, my voice breaking to anyone else?
I think maybe it could be it's the network, because I can
Oh,
hear
okay.
you are flowing.
Yeah. Oh, okay. And to try moving around or something and see if it works for you. So, like I was saying, I would need to know my balance, right? But this case, my balance is in this class, right? And there may be certain performance, there will be certain things I would need to take from here, like this balance over here. See, I'm calling balance here, like the way it's over here. So I'm calling this particular balance from this class. I'm not calling it from any other way, this particular class. So I will, sorry, in order to avoid repetition of code, or to um, relate to particular variables, especially in this init statement. Because I said this initialization statement, what it does is this particular method, what it does is it's a global method. So whatever you need, like I said, you can pass this to any other method without having to like specifically call it, like having to specifically call any function. You just call it like it was a variable that is there, like yes, it's a local variable. So in that case, we need in order to perform these particular functionalities like this, we need this, but we need a balance. We need a balance in order to know the current balance we have over here. In order to deposit, we need to know the current balance we have to add the amount we need. when we need to withdraw, we need to know we need to know the current balance we have to withdraw, because if we don't know the current balance, we can't withdraw. And I want to create a savings account. And this savings account also needs this balance and also needs certain functionalities maybe in the future when it's needed. So when we inherit from this class, what it does is it picks the super init. When we use super init in this case, it's under this function, this method, sorry, it's under this init method. And we say super dot init. So it's like we are calling this init method right now over here. That's what we're doing. We are calling this init method. So we're saying, okay, super, pick this init method. Just take everything here and put it here. That's basically what we are doing. So we have every functionalities of this init method right now. And if whatever I pass here, it's being replaced here. And I can use that to perform other things I want to perform in this class over here, and also in this class without any problem. So what we do is, when I use super init here, initially it is 0, as you can see, but I gave it 100 over here. So when I print this right now, and I do, I just print, let me replace the print statement. It says initial balance is 1,000. And if you can see, it says savings account. This savings account is a new object. I didn't have to call. I didn't call it. When I didn't call account, I never called account. I just called only savings account over here. And when I call savings account, I just passed it 1,000. I can take out the interest rate because I've already assigned 5 over here. So I called it only 1,000. I only called 1,000 to it. When I called 1,000 to it, I did a savings account dot balance. But if you realize something, dot balance isn't here. Dot balance too isn't here. But dot balance is over here. So I was easily able to call the dot balance because the super init over here assigned this value here to this initial balance, which assigned it to this init over here. And this super init, as we now know, is this init method over here. So I've assigned 1,000 to this initial balance in this init method. So I can use 1,000 inside this here separately, but I've also assigned it over here, in which which has replaced this over here. So I can now call get balance, I can call deposit, I can call withdraw, just by doing it once over here. I didn't have to call account and pass account into this. No, it was just one. I just called it once. And when I did that, I could easily use the accounts class method over here, get balance. Although, even though it's not here because I inherited accounts over here, I was able to call get balance over here. And when I called get balance, which is over here, I still got the balance, which is 1,000. Is that making sense at this point? If it's making sense, let me say a thumbs up. If not, or if there's any
So
part you think
basically,
yeah.
it means that the super init overrides the initial init.
Yes.
Okay.
It will write the initial init. But in this case, yeah, it will write initial. So in case maybe the init, initially I had a balance of what I can do was I had a balance of 0. Yeah, it will overwrite it. Yeah. It overwrites it, or it gives it a value. So if there's no value to it, gives it a value. If there's a value, it overwrites it. And the reason why it's giving this value is because you can realize that the get balance needs this balance variable. This balance attribute in order to perform its task. So without that particular balance, it can't perform it. So with the super init, instead of us now having to call class here and say maybe new class, new class and do accounts to pass it and come along, it comes and now have to pass this to maybe the savings account, in which I don't think it's possible. But like to be passing them, it's easy to just inherit it and pass it over here once, and you can get your balance and you can get everything that's or any functionalities that account has. As long as you inherited it, you can just get everything here and use it inside your savings account. So when I just called it get balance over here, I was able to get balance from my account class initially. So you can have multiple classes and can you have one main class where that's every other operation for you. So you don't have to be going to any other class. The classes will just do everything for you. One class can do everything for you because you have inherited all the other classes inside that class and it's doing your work for you. So that is the beauty about super init.
So is it possible that the super init can also be overridden?
Um,
Since the super init overrides the initial, is there an instance where you can also override the super init?
yeah, you can override the super init, but I don't know. You can't really. I don't. In what sense? I'm trying to. I get to your question. I'm thinking of I was thinking of how to implement that. So super init initially takes this, right? That's why it takes. So yeah, you can overwrite it. That is if you are working with only accounts. Yeah, if I'm working with only accounts, it won't even take anything that is considered over here unless you are inheriting savings account inside account. Yes, and you can, and that one doesn't matter because the moment you call the new balance in this account, it will overwrite anything that you've kept here. But in this case, yeah, so it can be overwritten. It can be overwritten depending on what you are doing. If you are calling this class account again somewhere else, so in case maybe I do a savings account is equal to 1,000, and I do a class, sorry, new class, and just say account is equal to 2,000. When I print new class, no, this will create another object. Don't override, but just create another object of the class. I don't think you would have. I don't think there will be a need to overwrite it. I don't know if you try. I don't know if you get what I'm trying to say in Taiwan.
Okay, I get you.
Yeah, because if you want to initially use it over here, you just call the account. You just call account. Yeah. So this right now we won't even need the savings account here currently. We will just call account here, and the account will do everything for us over here because we're not inheriting from super init. If we're not inheriting from savings account, we won't be able to use any functionalities over here. But
Oh, okay,
if
so
we
you
are
can't inherit from a super init.
no.
Okay,
Unless
okay.
I
It's
unless
clear.
I pass this, yeah, unless I pass this savings account over here to this account, then I can use everything here. But I
Okay,
haven't personally of tried to overwrite the super inits. Yeah, because this may have a value, but you can just overwrite it. And so the most important in it is just to help you overwrite another class's own, another class's in its function in its method. Yeah. Or change another class's in its method to your in its method in that class. To your value, and you would be able to just change everything as you want. But I haven't personally tried to overwrite super inits. I'll look into that. I'll look at which scenarios that can help, and I'll let you know. Yeah, but I don't think it's most something that you mostly do. Yeah. Yeah. But so just know that the super init overwrites or gives the value to another class, not its own class. It's used for another class that you've inherited, not its own class. Yeah. But you can also change it. You can change the same way I have a value here. This value is for this. So I'm giving the value to this class, but I have passed this value to the super init, which has given it to this balance. So I'm changing this balance with the super init. Yes, but I'm still having the same balance over here. So if I change this balance, it's also change the account name to another account to another. If I change the balance, to change this balance to that balance that I've changed over here. That's what it does. Yeah. So it's 10,000 now. Initial balance is 10,000 now, and you realize that even I did here. You say service account or deposit, right? And I deposited 500. I didn't have to go all the way to account again to now give it a value and deposit 500. I guess I deposit 500. So I'm able to even work with this account in my savings account. So even though I'm depositing in my savings account, it's an overall account. So it is adding up to this my account because I said savings dot deposit this amount. So in my initial deposit over here, this balance is now changed. So if I, as you can see over here, after depositing, hold on, there's a mistake. I think I've seen a mistake. Give me a second. The mistake is coming from this. This is supposed to work. I don't know why I'm getting an error over here. This is quite strange. So we do have really let me see. Statements might be separated by new lines or semicolons. Oh, this isn't supposed to be. It's supposed to work. I don't know why it isn't working. Let me see. It's supposed to add up to what's the. So let me use a print statement. Let me see if that works. Yeah, so I'll still get a syntax error. Work is it worked. I think there's. I'll fix this error soon, but this is supposed to work. Okay, let me do this. Go to self balance. Right. I'm making a mistake. I'll check this and get back to you. Because when you deposit, I deposited 500. It's supposed to show that I've deposited 500, but it didn't. It added, but it's not displaying. I don't know why. And I think it's from this particular issue, from this particular method. I would get back. I would find the issue and I'll let you know. But let's go to the withdrawal. As you can see, I took out 200 from the 10,000. So for now, let me just take out this because I'm having an issue, but I'll get back to it. So here, out of the 100,000, I'm withdrawing 200 to go and do something. So when I withdraw, you realize I got 98,000 over here. So when I was withdrawing, it did. Oh, okay, sorry. I think I've seen the issue. I gave it a return statement. So it should be working now. Yeah. Okay. So yeah. So it appends. I'm not supposed to return anything. Yeah. Because I am just adding. The reason I'm not supposed to return anything over here is because what I'm doing is balance already has something. So I'm just saying, okay, balance plus this. So I don't need to return the new value. If I want to return the new deposit value, I'll just return balance. This is why I'm not returning anything. If I need to, because I am here, I'm just depositing. So I'm just adding money to the balance. So it updates this balance over here. So I don't need to return. Here I'm just returning it because I'm just returning the current balance I have. Here I'm returning a string or something, but here I'm not returning because I am appending or I'm adding to this particular value. So all I have to return is this value, not this deposit, because this is just to deposit. It's not to see my value. So that's why that was a mistake I did over there. So when I deposited over here, I got this amount I had. So I added 500 to it, as you can see over here. And when I withdrew the 200, it was able to do that. When I calculated my interest. So okay, so these amounts I have currently. So with this amount, because I got the balance over here, as you can see, I have get balance over here. So my current amount now is this, and with this amount, I decided to calculate my interest rate. That is add interest rate. So now this is where we even use the method inside savings. Initially, we weren't using any method inside savings. Savings only had these two methods, and even is the main particular method. So where all the functionalities we're doing over here will belong to this account class, but we're performing everything in this savings method because we needed to do certain. We needed to perform this addition, this interest rate. So as you can see, we have our interest calculation over here. That's the balance times the interest over 100, and right now when so if every month I get the interest, I deposit the interest into my new balance, and it returns my new interest for me. So yeah, so what I did was yeah, it returns interest, but this is my new balance. So when I initialize the interest over here and I say okay, interest end is equal to the savings account. So that's just the savings account that initially had 10,000. Yeah, dot add interest. So my current balance now is this current balance right now, and I am calculating my interest. So this is my interest right now. And in my interest, I am adding both of them. That's it's saying over here. So I'm adding my interest. I'm depositing my interest. So I call this method the deposit to deposit the interest I have. That is over here. So as you can see, I call deposit from here, and I use it here to deposit the interest. So in this case, this amount now is the interest, which is this amount right now, right over here, and I'm depositing it into my new balance over here. So my new balance is now this amount. So you realize how we were able to inherit from the accounts, and we were able to just perform other functionalities and everything in the savings without having to call accounts separately to assign all the values and call class and to call this class two separately and do all this assigning again. That would have been very tedious to have to put all this code here again just to calculate interest. That would have been very tedious. So when we just inherited, we were able to perform all these functions and call it so easily, like the way we normally call it here, self does this. We just called it self dot deposit, and we just deposited money over here. We were able to call a method inside the account over here. Although we were using the savings account class, we were able to call a method inside the other account section over here, and we were able to perform our interest and now deposits using this accounts functions over here to deposit the interest back to this balance, and we got our total balance over here. So that's the beauty of inheritance. That's the whole concept of inheritance, allowing you to use other classes to perform things that you would have done instead of having to copy that whole class code into the new class code and do it all over again. That would have been very stressful, especially if you are trying to structure your code well, because maybe you may have current accounts, may have savings accounts, may have maybe dollar accounts, and having all that in just one account class would be quite confusing with a lot of methods. So you separating them and you inheriting maybe in case you need some certain functionalities from the account, you can just inherit those functionalities and just use it in your current class without having to recreate it all over again. That is the beauty of inheritance. Do we get it up to this point? Do we
Yes.
is it making sense? Okay. So that is it for inheritance. I think you have closed. But we're supposed to do this exercise. No, forget about no, not this exercise. Yeah. It was going to be quite simple. So I don't know if maybe you guys will just try it out and tomorrow morning when it comes, you guys we can just talk about it. It's going to be actually quite so it's you have to create a class. Yeah, if you agree, okay. Okay. So we just I would even copy this. I'll copy the question back. I'll copy the question to the group for you to work on. But basically what you have to do is you have to create a student class, right? Which should store three types of information: the student's name, the student's age, and the student's grade. And the class should be able to update the student's current grade. So if the student's grade is 3.5, I should be able to update the current grade to maybe 4.5 if I want to. And the age, I should be able to also update the age in case maybe I made initially the certificate the person initially brought had errors, and the person to do that affidavit or something and decided to change his age. You could just create another. It should be able to also update that age, and also you should be able to display the you should be able to display the student's details in this way. Student's name. You can say student's name is student's name should be and the name of the student. So name of student. Then you can have a student's age. Student's age or student age should be okay. I think it's not working. Let me will this work? So that would be name, the age, and that would be we'll have that's all student's name and student's age. But you could have grade too, yeah. So student grade over here, which will be grade. So this is how it should display. It can be in a string. If like so you can just have a string, a formatted string that will do that for you. So let me just give you that hint right here. So this curly braces will be the student's name. That's the name that you provide for the student. This one will be the name of the age of student. So age of student over here, and this here would be the grade, student's grade. That will be grade. Yeah. So you can put in the formatting. So to return, so we should have one function that would return all this, one method that would also return all this. Are we on? Do we understand the question? Or if like if I want to go through, if I want to go over the question again, I can go over. I'll paste it again in the channel for you to work on. So that's going to so just something simple. I want to just you guys just have a feel of how classes are. And please just go through tomorrow, talk about it. And we'll talk about the errors you encountered. I know this year you encountered of errors. You let us know the errors you encountered, how you solved it. If some errors you couldn't solve it, we would help you because one way of learning, one way how I learned coding in particular was I had a lot of errors when I was learning coding initially. I had made so much errors, and because I got to know these errors and I got to correct them, initially I got and I now know that if when I'm doing something like this, I'll get this error. So I have to do it like this. And I was able to kind of pick it up with experience. So I think that's the experience part. So just do it, get the errors, try and fix the errors. That will help you understand what you're doing when you're fixing the errors. Feel free when you have any issues, feel free to ask and we'll talk about the errors. If you couldn't fix any errors or any issues, we'll talk about those issues and which should help us understand this example. So after we do this, I think that will be it for classes. Then the questions that Stephen, please correct me if I'm wrong. So after this, after we go through this tomorrow, the questions that you guys gave, or the areas that you guys don't understand, we would tackle there again and do more examples in that point, in that particular place, for you to understand what is happening. Stephen, is there anything you need to add?
Um, yeah, so I'll be sharing a notebook file with everyone, and you can start trying your hands on the example questions that are in there. And this is just to help you identify where your strengths are and where your weaknesses are. So when we meet the next time, you can help us. It will give you more information on what you need help with, and we can go over those specific areas uh, more into more details, and it will help everybody to be on the same page. So I will share this on the link, then everybody can pick up from there. Um,
Stephen, so should I give you this to add to the notebook,
yeah,
or
yeah.
that's this?
Share with
Okay,
me.
so okay,
I'll add it
okay,
then.
all right,
Give
all
everything.
right,
Right.
okay.
I've also pushed it to GitHub. So even if you go to the GitHub, you should see right now over there. It's Q and A. That's the name of the file. Q and A. Q underscore and underscore A. That's the name of the file. So you can even go to GitHub and download it from there, but I will share it separately so that everybody will have access. And if you have any challenges with the setup and all that, you can just text me and we'll make time to resolve all of that issue before we proceed. So yeah, that is it for my side.
Mr. Isaac, please, you said you see me after. So if you can, after this, you can text and if there's any problem.